I think we're live. Good evening, everybody, and welcome to stream number 18. I can't believe we're already on our 18th dev stream. As I mentioned during my stream last week, I was thinking about giving my vehicle demo a little bit of love. Mainly also because right now with my space game, I'm at a point where I need to spend some time off camera just working some stuff out to prepare the next steps that we need to do, but also because there's been a lot of questions about this project and the fact that I haven't been doing tutorials here anymore, and the current project on GitHub is slightly outdated by now. So yeah, I thought that would be nice to do just for at least one stream. Might make it 2 streams, I'm not sure yet. Depends a bit on how next week will go and how far we get tonight. So yeah, that's the main focus for tonight. The other thing is I changed some setup things, so I hope everything is working. I hope my audio is working, so let me know if there are any problems. Why is YouTube trying to tell me new things in the middle of a stream? That doesn't make sense. So let me know if the audio is working or if there are any problems with that. I've also got my fan running this time because it is getting pretty hot in this room. So I'm hoping that I've got everything set in such a way that that noise isn't being picked up. Again, let me know how it goes and whether that is all working the way that it's supposed to. Which actually reminds me that I really do want to check my audio for a sec. So hang on for a second. If my wires don't get stuck on things. Yeah, seems to be getting audio, so that is really good. All right. I have been working on the vehicle demo on and off in the past year, just cleaning some stuff up. So you'll see that there are a few things in here for those who have followed my tutorial series on this. For those who are unaware of my tutorial series, they are already a little bit older, but playlists. Oh, I have a like videos playlist. How nice is that? Where are you? No. Here we go. Get over here, tutorial. So there is a playlist for the series, and I don't actually want to start playing that. So we were up to 5. And these have, a lot of people have loved these because it's one of the few tutorials online that shows you how to set up the vehicle body in Godot. It is a bit of a, how do I say it? It's a bit of a temperamental beast. The vehicle body implementation was originally based on the Bullet version. Then, of course, Godot adopted the Bullet physics engine, but the vehicle body implementation is still a bit of a hybrid between the custom vehicle body implementation and the new Bullet physics engine that was implemented. So there are a few little twerks to it and then tweaks that really need to be done. So yeah, but this tutorial series gets you through a few things. We're also setting up a track, so I'm using a CSG path to build up a track. And then in the last part, I actually, as a fun project, I moved it onto VR so that you can actually play the game in VR. So yeah, so one of the things that I've already done, that I've already been working on since then, is that the game now starts with a selection screen, whether you want to run the game in desktop mode or whether you want to run the game in VR mode. And the way that it does that is it simply loads up a subscene into our scene here that sets up that specific view. So we have a construct desktop scene here that we load in, and if we go look at that, all we have here is our construct environment. So oh, that's the other thing that I built in here. I put my background loading logic in here, so you'll see that all the elements from that are in there. That is actually implemented in a base scene, which is called construct. So both my VR scene and my desktop scene, they inherit from that. And one of the things in there is a node, which is the player node, and I am updating that player node to the position of our car. And that's something that I still need to look at, because I'm not quite sure if that's working the way that it is intended to work. In VR, you'll see that it's the AR/VR origin and AR/VR camera that is on here. We're not dealing with controls here because of the type of game that we're doing here. So it's purely the origin and the camera. So the origin will be placed where the player's head is, and the camera will then, follow through on that. And there's a few more things that we need to improve there. Hi Joseph, thank you for joining. Yeah, live is maybe a bit of a big word. I'm not quite sure yet if I'll find the time to actually do a part 6, but I think it makes sense to at least spend some time on stream on this, so that there is some continuation in the in this project, because there's quite a lot of requests for that. Ishmir, yeah, well, we have had plenty of discussions about how we do things, and had a lot of fun. And one of these days we need to get that little go-kart game of yours finished. I know that we're working on a bit of a bigger project right now, but that go-kart thing is still a fun thing, so we do need to do that one time. Hi Angela, how are you going? Thank you for joining. Okay. So that is the way that I'm doing that. So we're basically in that startup screen. I've also got a little tick box whether our preview screen or our main screen is going to be full screen or windowed. So if I just run this and I just select desktop, I just get a resizable window once it loads. There we go. Boom. Car really got thrown into the game there, and that still works as before. Now the idea that I have here is that I actually want to have obviously a screen in between there. I don't actually want to be thrown into the game right away when you do that. But that's something that we'll need to look at some point. And then the other version, obviously, and I'll tick the full screen for that one just for fun, is the VR one, where I obviously need to pick up my VR headset and center my camera, because that is not being done automatically. And there we go, we are inside of our car in VR. Now I am sitting a bit too far back. Again, I haven't actually touched this project often anymore. Where is my controller? Here's my controller. And that does give some problems, because there are some issues with the camera moving depending on how fast I'm going. So if I slow down, you can see that I'm moving forward. If I speed up, I'm actually moving backwards. And I'll end up sitting inside of the headset, or the headrest of the chair. So there's a few things to fix there. Oh, look at that! I'm going really fast, and now I'm actually behind the driver's seat, which is not what we wanted. So yeah, a few things to fix there. It did not open up full screen. That is not good. So yeah, work in progress, and that is something where we want to continue tonight. So obviously I want to start cleaning up the rough edges that we have, after I fill up my glass of water. Oops. Sparkly water. There we go. So yeah, obviously I want to start cleaning this up, everything that I've done so far. But that was in the way. But I also want to look at some of the other functionality that I was going to work on. One of the things that is really a bit sad is I lost one of my hard drives about a year ago. So I had a version of this project with a lot more things implemented, and I lost that one. So we have to redo a few things. And that's actually a nice little journey to try and do on stream, I think, to sort of reproduce those things. All right. So let's first have a look at why our full screen wasn't working. Oh, I can see why our full screen doesn't work, because we're not doing that in VR mode. Now, that does make a lot of sense. I'm wearing the headset. I don't need it to be full screen on the screen, but I am actually going to put that in here because we have our tick box. There we go. Because when I'm demoing it like this, or when I've got spectators, I actually want it full screen on here so that people can actually watch what I'm doing. So I don't agree with what that originally said. All right. Now there's a couple of other things that weren't working, and I think I just haven't re-implemented that here. One is that I had this logic that if you move too far away from the center, from our origin point, that the screen would go black. So that is something that we need to do. This is important when the player isn't actually sitting properly in the car. The other thing, of course, here is I probably want to do my center on HMD automatically at some point in time. I'm not too worried about it. Oh, that's the other thing, which is kind of cool. I am using my my very early beta version of my of the OpenXR driver here. So what you was just seeing running is actually running on the OpenXR driver, not on the OpenVR driver. Sorry, I misspoke there. I think I've talked about this on stream before, but just to recap real quick, Christopher Haags has been working on an OpenXR plugin in Linux for Godot, which he built to test out some of the Monaro features that they were working on, because he's part of that project. And that was all working basically as far as the core of the driver is concerned. So rendering to the HMD, he's got basic controller support in there. It's all hard coded, but it's a working driver. It's really cool that he was able to do that amount of work in getting everything up and running. But he only does stuff on Linux. So I talked to him a couple of months ago, and sort of said, do you want to? Because it was still part of his own GitHub page at that point in time. So I asked him whether he wanted to share this on the Godot VR GitHub page, and if he wanted to have my help in getting it up and running on Windows. And he agreed, so we moved it over to the Godot VR website, and we actually merged the first round of changes to make it work on Windows. As you can see, it is running on Windows. Has been running on Windows now for a few weeks, but we've been tweaking it. And it needed some upstream changes, which, as far as I am aware, have been merged into the 3.2.4 beta build. So with the beta. So with the latest 3.2.4 official beta, you should be able to use the OpenXR plugin without any problems. Knock on wood. But it's still very early days. There is a lot of work still to be done to make it feature complete and to really make it do cool things. That said, it is truly cross-platform. Microsoft supports it now, Valve supports it now, and Oculus supports it now. So for all desktop VR solutions, OpenXR should allow us to run all headsets. So that's pretty cool. Morning, David. How are you going? Thank you for joining. So I wanted to just experiment a little bit with the OpenXR driver in here, and I'm probably going to keep that as the default driver here because I don't need controller support and all the stuff that's still being worked on. So as far as the base functionality is concerned, it does what we need it to do. The rest of this is all pretty standard. There's not much code in here. We're turning our viewport into an AR/VR viewport. I am just turning the main viewport into AR/VR. I'm not doing anything special there. Turn VSync off because we're running at a higher frame rate than our monitor is running on, and setting our FPS to 90 frames per second. Again, this is something that really should be loaded out of the plugin, but we don't have that functionality at this point in time in OpenXR yet. This logic is to center the HMD on our current position, so we go straight back to sitting in the car. Important, like my startup just now is my headset is on the table here, or on my little desk here. When I start the game, that's where my head is. The moment that I pick it up and I move it to my head, I'm suddenly outside of the car looking the wrong way. So that is why That center on HMD is very important, which of course is something that we want to do much earlier in the process. So right now we're being thrown straight into our game. It's the same problem that I have with my space game. We're being thrown straight into the game. The moment that we have the first scene that we load being the environment in which the user, sets up the game, select the car that he wants to drive, selects the track that he wants to drive, select the mode or things like that. The sky's the limit how far we can take this. Then that is an environment that you can actually make more agnostic to the position of the headset. You could scale everything up so that basically if you move a meter to the side, you hardly notice that you've moved much because the environment is that big. Or, just reorientate the world around where the headset is and slowly move things around. There's ways to do that without immediately invoking motion sickness. Yeah, OpenXR support is long awaited, and like I said, there's still a lot of work to be done before that plugin is on similar level as our OpenVR and our Oculus drivers. On the note, by the way, on the Oculus, I did a extra stream last Sunday. If you guys missed it, you can see it in my on my YouTube page. I keep all my streams around on my YouTube page about setting up the new Quest drivers. There's some structural changes that happen to the way that the Quest plugin works. So my earlier tutorial from a year ago, something like that, that's been superseded by a few things. There's a lot of similarity, but there's some fine details that have changed, especially if you're compiling from source. So that is up and running as far as the Quest is concerned. That is the current version, the current master still at this point in time is the last version that will support the Go. Is also a version that currently is linked against the SDK that is based on the Quest 1. So you run in Quest 1 compatibility mode on the Quest 2. But it runs on Quest 2. I've heard from Freddie, he's tested it. Everything is running on the Quest 2. But we're looking at moving to the latest SDK version, which means that we're dropping Go support, because unfortunately Oculus has dropped Go support from their SDKs, and implement the few added things that will allow us to use the new features on the Quest 2. And we don't expect that to take a lot of time, so look out for that. It's probably going to be around very quickly. Looking forward to trying out a Quest 2 myself. Unfortunately, I still have just got the Quest 1. Although it's a wonderful device. My kids love playing with it, and I love playing with it. So anyway, back to this. So I actually don't want to spend too much time on the VR side of this. I added VR support to this game in my last video purely because that is something that I like to hobby around with. But the vehicle demo was always intended to be a desktop game. So I really want to proceed with building it as a desktop game and just checking if everything still works in VR as time goes by. That said, I do want to have a look at what happened to my fader. So this is the fade to black that I'm using over here, which blacks out the whole screen without. It's actually for the movement between. I can't think of the word now. When we're loading scenes, so when we're going from our entry scene to our full scene. So that's not the one that I'm after. That's our loading scene with a black environment. That's our test scene. That's a track. What's our test scene actually? What's in there? That's an empty scene, so I'm not quite sure what I was doing with that one. There's my car script for my car. Again, I haven't touched this for a while, so I also need to sort of remember where everything is. So here's my press B and my message material, my message shader. But, this is my old VR camera thing. So that one I'm no longer using. That's some of my old code. But I need to reproduce this guy over here because that uses my little message shader. So all that we're doing here, and we'll actually dump that in over here. So I want that one centered on my camera, I think. No, I just got that centered on my origin point. That's fine. So we're going to do message sphere. Oh, no. I always make that mistake. Mesh instance, and then we're going to call it message sphere. There we go. All right. Well, we're going to keep showing it for now. So I'm just going to go and copy this over. So 50, 100. I don't really care about the rest. And then the material, obviously, I've put on there. Okay. So that's going to be a sphere. Boom. And 150. So it's a really, really big sphere, which we can't see because we don't have far enough. Oh, we should still be able to see that. That's interesting. But I do want to have that big anyway. There we go. Interesting. Oh, because I'm in the inside of the sphere. That's why I can't see it. But anyway, the moment that I go and load up my material, actually, I want to copy that file. Let's do that first. Tutorials. Here we go. Because obviously this is all my old stuff. Yeah, that's all my old stuff. So I'm not going to be keeping that. I'm going to go copy that, copy that, copy that. And we're going to put that into, where is our structs, I think. Yeah, we're going to put that over here. But I do want to have a sub window there, or a sub folder there called VR. There we go. So now I should be able to say load scenes construct VR, and there's my message material. Wonderfully black, but with a message. Now this is all compressed and looking weird in the editor because the sphere is meant to be rendered properly inside of our headset. So that is why that looks weird in here. I do some really funky trickery in that shader because I am basically playing around with my positioning here. Now, interesting enough, yeah, I'm doing the projection matrix. Why am I not doing that exactly on one? Not sure. Don't think I really care too much about that. It's probably because my near view is at that. Yeah, that's my near. That's why I put it on there. So I obviously don't want that in front of my near plane because then it will be cut off. I want to make sure that I black out anything, even though it's a big circle, and I'm using a circle because that gives the illusion of depth of the message being somewhere in front of me instead of being right there. So that's why I'm putting that in a circle, but I don't want that circle to actually be around my world. I want it to completely remove my world and make sure that I can't see anything about my world. And the way that I do that is I set the Z position after projecting it to the near plane, so that when it then is processed, it will come there. Now, I'm not 100% sure if that is actually important to have, but as long as it's a small number, it should be pretty good. I'm actually thinking, let's see if it still renders if I just make it 0, or does it then disappear? No, I'm gonna, because this is after projecting, so that should already be depth adjusted, with 1 being far away and 0 being right up front. So I think I did that wrong when I originally wrote this. I think I can just keep that 0. Actually, interesting enough, I did just edit that in the wrong place. So let's go to the actual shader that we're using, which is this one. Let's see if it still works. If I change that, it looks like it still works. All right. So when we are looking at our sphere, our message sphere, our material here, we'll see that we actually have the image selected here, which is our press B to center the headset. And that is just a square texture with a black background to draw that that text. Now B is actually incorrect because when I wrote this, I was using my trusty Where are you? My trusty Xbox One controller, which has a B. But I'm now using my my Sony PlayStation controller, and it has a circle. So that's something that I need to figure out. Well, make it nice and message. Maybe somehow change it depending on what sort of controller we have. I'm not quite sure yet how we would do that. But I just want to have a look at what this actually looks without any further logic here. Because obviously we need to make this do the right thing. Okay, so that is actually squashed. So, interesting. That used to work properly. So I wonder what changed there. Maybe I've got my settings for my sphere wrong. Radius 50, height 100. Yep. That would do it. There we go. Simple mistake. Okay, so now that looks the right proportions, and it actually looks properly in the editor here too. But all that we're doing here is, if the player is too far away from the car, we want to show this message. Now there's a little bit more logic that needs to happen here. So I'm going to copy that from what I originally wrote when I did my original tutorial on this. And again, you can see this is all the original OpenVR code. The same center is in there, but now we suddenly have some code that updates that center sphere. So we're just going to copy that into our VR one, which is this one, and fix it up, because obviously everything here is not correct. Now, did I use any? No, I did not. I actually want to have some convenience values here. That's going to be... Does that not autocomplete because it's still... Alright, no, that's because there's no var in there. Player. There we go. Camera. So that's how we get our camera. There we go. So I want this guy to be camera. Do I have the camera anywhere else? Just put it over here. Max distance, we can probably just copy from here. There we go. I also think I need to copy that alpha value. Pretty sure that is used somewhere here. Yep. So now we just want a center sphere. So on ready var center sphere is player. Actually, I'm going to call that message sphere. I'm not sure which one would be a better name, but we already named it that. So we do that. We do that. And all this code does. There we go. There we go. There we go. And there we go. So all this does is it checks whether the distance between our camera and our origin point, because I'm just taking the translation of my camera, so the local translation of my camera. I'm checking whether that is, what the distance of that is, what the length of that is, and if that is beyond my max distance, which is currently set to 0.3, which is 30 centimeters. So if I move 30 centimeters away from my chair, I'm going to make that sphere fade in. And that will show me my message and tell my user, go and center the camera. So let's see if we've done enough. So yeah, we see that our center B for our headset is still showing. I really need to do something about my wires here because everything is getting crossed. Alright, so if I hold my button, eventually I am now nicely in my car. Alright, cool. And I can drive around again. Alright, so now if I grab this guy and I go away too far, my message comes back, and when I'm in my proper position again, it disappears. Alright, now I remember that I originally also had that message rotate to face me. But I would have expected that to be in here then. So maybe I did that in a different project. Or did we miss something? No, because we're getting in a camera translation. Well, we can add that pretty simply. Because we'll want to have our camera's looking direction, so our degree Y, to match our sphere. So we're just going to lerp that together. Excuse me, just keeping in mind that, you know, we obviously could get the wrong way around. Actually, that also reminds me, at this point in time, I really don't care about that logic anymore. So we're actually going to go, and that's in our construct. So don't want to delete that one. I want to delete my old files over here. Goodbye. Because we're no longer using that. I'll check whether there's something that we want to reuse here later on as well. Why is that? Oh, that's because I still had it open here. So go away, you. It's fine because I deleted it. So yeah, you can't save it. This is why you should really be deleting these files from the Godot interface, not outside. Is there anything else that it complains about? That's GD scripts. No, it's purely that file where we still have that open in our editor, so it wasn't happy with us removing that. All right. So the other thing that we want to do here is align our sphere with where we are looking. I'll have to react to that later. Boom. So yeah, what we're gonna do here is again, because these are both children of the same origin point, we can just look at our local translation. So we can simply calculate our rotation delta is I always need to remember which way around we need to do this. Is it sphere dot translation dot, no, do we just have rotation then? Yeah, we do. Rotation dot y, take away, no, actually we need to end up with our camera's rotation. All right. There we go. So we're going to get a difference between those two. However, we need to be aware that if we're rotating the other way around, that might become bigger than 180. So we need to both check if it's smaller than minus 180, and we need to check whether it's bigger than plus 180. And then we'll want to subtract or add 360 to it. So if rotation delta is smaller than minus 180. Sorry, that's not 180, that's pi, because I just got it in radians, not in what you call it? Not in degrees. So yeah, 2 times pi to it. Else, if rotation delta bigger is than pi, and we're going to say rotation delta minus equals 2 times pi. I hope I got that right. If I remember, that is the way to do it. So that should mean that we're within that 180 degree sphere that we're always going to go, or actually it's all the way around. So either this side around or that side around. We're now going to trace the shortest path to make them align. I hope. And then we're just going to say message sphere. Actually, what I want to do here is if message sphere visible. I only want to execute this logic if we can actually see our sphere, else it's just wasted performance. Plus is rotation delta times our time delta. So that basically means that within 1 second it should align. Okay, small delta. Without a comma, please. Alrighty, let's see if that works. Let's go back to full screen. Let's go back to that one. And keep that. Oh. Is that just not loading or? Okay, did we get into an error? Construct makers. Okay, so we might have. Oh, of course. Ha 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 ha. Yeah. Okay. Again, don't copy files in your Explorer. Copy them inside of Godot, because our material is not using our shader. It's still using the other shader. So now it's going to say, "Hey, I don't get that one." And we're going to go and fix up our shader. VR shader. And we're going to fix up our image. And now it's happy. Open anyway. Save. And let's see if this time it loads without an error. So now you can see when I move my head, our message will slowly move in the direction that I'm looking. It doesn't do it right away. It moves it slowly, and that is important because else you get disorientated. And now obviously if I do that, I'm nicely in here again. All right, there we go. Sweet. Cool. Now we... Okay, don't hold your headset on parts that can come loose. I almost dropped it. My face shield sometimes. Well, it's held in my magnet, so if you don't hold it properly, it does fall off. Now, the other thing that I noticed is when I actually reset the headset, then obviously this logic gets run that changes the orientation of our camera. To make our camera snap to the player position at this point in time, and that changes our relation to our excuse me, let's actually open this guy again so that I know what I'm talking about. That changes the orientation to our message sphere. Seeing we're fading out, I'm thinking that it makes a lot of sense. Does that work immediate? I think that is pretty immediate. So I think that makes a lot of sense to say here, message sphere dot rotate y. Nope. Rotation dot y is camera dot rotation, to snap that in position right away, because now we should be getting that we're not snapping that suddenly out of place. So I'm just gonna hold my headset this time like this, so we get that center B to headset there, and now I'm centering. Okay, was not expecting that. So I am thinking that this actually doesn't apply to our camera until the next frame. In which case, we're gonna put a was reset as false. Then actually we need to do this afterwards, don't we? We're gonna change this around so that our next process loop, we're actually doing this. So I am moving that over there. There's madness to reason to my madness here. Was reset is true. So we just reset that thing. Very good. Here we're gonna do if was reset. I'll say that. So we're just gonna move this over here. So if we put it back in false. So if we've just reset our view, that's when we're going to trigger that logic. I think that'll do much better. Let's see if that works. So here's our message again. Something's loading. There we go. Oh, my GeForce experience. So let's reset. And now we see that our message stays where it belongs instead of suddenly being in a different position. Now, if I happen to be moving my head as I'm holding my my circle button, then yeah, that would still move it. But I can live with that, you know, because that will only be a tiny movement, a tiny adjustment. It won't be, you know, halfway to the right like we had just now when we had this big reset. So yeah, now we have logic that if our head is not in the right place, we black out the screen, we get a message, please hold the button. And obviously, you know, like I said, we'll need to change that message out depending on which controller we're holding. But that's not for today's stream, I think. I could change it on button release, but that's not actually the problem. The problem is that when I'm calling, well, actually, I'm not doing it on button release. I'm doing it on holding the button for a certain amount of time, so that if you by accident just tap the button, you don't suddenly get your position reset. Because again, you know, you're driving, you can't see your controller. You're using the buttons to, you know, switch through gears or something like that. It's very easy to accidentally press the view reset button. So you really want to have that hold down for a little while. But the other problem is that when I call center on HMD, that resets my camera's position in the AR/VR server, but that position isn't updated on the actual node, the camera node, until next frame. And that is why when I did that right after the reset, I actually didn't have the information available yet to properly react to that reset. And I need to do that in the next frame. That is something that is currently undergoing a lot of discussion. There are some interesting PRs that have been put into place, especially when people are running Godot in multi-threaded mode and having this physics running in a separate thread. That has some weird side effects in the way that this is currently structured. But this is a decision that stands back, you know, 2-3 years ago when I first worked on this. And we're probably going to reevaluate that pretty soon as we start adding VR support to Godot 4, and possibly changing the order in which things happen. In which case, you know, the center on HMD would probably reset the position right away, and you have access to that. I've got some ideas about that. Not 100% sure yet whether they will work. Okay. Getting Godot to work on ARM. Isn't ARM, you know, aren't all Android phones running on ARM? So I'm not sure what sort of hardware are you doing that with? Because in theory, the Android build should be an ARM build, so it should work. Don't see why not. You know, they've even got Godot running on Raspberry Pis. So, hey Dragio, nice for you to join again. All right. I think that is everything we need to do with the reset logic. And I think that's really everything we need to do on the VR side of this. So let's concentrate a little bit on desktop. Now, right now on the desktop, we just have our fixed camera in our player's position. But I believe that this has the same problem as I have in VR, that when I'm driving, the faster I go, the further my camera is. And the reason for that is because I'm copying my camera position, or my, there we go. I'm copying my origin position, or my, actually let's open that thing. It's easier to talk about when I'm actually opening it. Where are we? Where's my cars? Assets, I guess. Should be in scenes then. Where is my car gone? Track. You can see that I haven't touched some of this stuff for a little while. So yeah, that's our track. There's my car. Let's open that guy. So where is the scene? Oh, it's straight into... Why is it like that? That doesn't make any sense. Oh, because I'm inheriting from that, and then I've built everything on top of that. Alright, that definitely could do with a lot of improvements. But for now, that is fine. So I have got that probably then all directly in my Caterham thing. So is that true? Is my scene here too? Yeah, my car scene is in there. So yeah, that's another topic for another day, I think. But this isn't very friendly if we want to have multiple cars. So not quite sure why I wasn't smart enough to nicely create a class structure for that. But that is definitely something that we want to enhance. But the thing that is important here is we have our driver here, boom, which is just a spatial. And then there's some code somewhere that assigns that to that. Okay, so that's our world construct. That's coming from our construct. So let's go into, and I don't want it in my desktop construct. I want to go into my normal construct, which is this one. There we go. In which we have some code where, let me have a look. Well, in our physics object, we're getting our camera follow, and we are updating that guy. And I think as a result, it's interesting. We're doing it in a physics process. Doesn't make any sense because this is only something that is important for that. Oh yeah, for some reason I couldn't get remote transform to work, which is exactly what I want to be using here because that's actually the one that works properly. Which I then want to actually set to our player. Okay. Well, that shouldn't be too hard to change. Not in our car. There's our track. There we go. And again, this needs to be properly subclassed from a base class so that we actually have control over that. But let's go and change this one. Change type. No, not rename. Change type to a remote transform. And a remote transform is going to push this position onto, or this transform onto another node's transform. So this needs to point to our player position. Now we don't get that actually, we just get our world construct. So we're going to change the way that works, and instead we're simply going to say car driver dot, what's this thing called? Remote path. World construct dot get node. I'm gonna hard code this for now because we've got a player node there. Obviously, I want to do something nicer there eventually, but for now, I'm happy to hard code that. And I want to get path from that. I'm not sure why the auto completion doesn't work there. Okay. So if I now go back to my main, no, my construct here. So here we're going back to a loading environment. So this now just becomes, oops, player. Oh, because I don't have that open. Oh, that's probably why my autocompletion wasn't working either. So player.transform Well, that's a good one because okay, our current world is already freed here, so we should already no longer have our remote transform active. So we're just going to reset our transform on our player. Boom. All good. And in this case, we're going to just get rid of that, which should also mean that our camera follow can now be removed. Where is our, here we go. Camera follow. All right, let's see if that works. Oh, busy. Let's see. Oh, cool. So Bailey, you're having a lot of fun with pies. All right, cool. I'm surprised that that doesn't already work though, because I know that there's other people who have been working on Raspberry Pis and having Godot run that, but maybe that's on a different architecture. I'm not sure. But it's cool stuff. The steering wheel moving was indeed already on the previous version, but I'll show how that works in a minute. It's not that hard to show. Hi SSLX, how are you going? Deformation system in the car mesh. You mean like damage? Maybe. Not on the short term. That's a pretty big thing to do. And we haven't even made all the stuff work for the car actually driving around. So, all right, let's see if our remote transform fixed our problem. Looks like it. We are now nicely kept in the right place. It's really cool. Now, one thing that I am a bit surprised about is that there's obviously a timing issue here. And I'm guessing it is because... Oh, that's an interesting one. I'm not sure why that's happening. My car is suddenly disappearing. I wonder what that is about, because I don't think I've got any code that hides parts of the mesh. So that's worth investigating a little bit as well. But I'm guessing that the reason why that was acting the way that it was, because I think the position of the camera was placed where the car was one frame before. Oops, get the guardrail there. Is because when we were copying it, the physics engine hadn't actually ran for our physics body yet. And that is, I guess, one of the dangers of doing things in a physics process step, is Godot will loop through all the nodes in your scene in a physics step to update each object that is controlled by physics. So if the car's update is handled after we did this logic, which is logical because we were doing it in the physics logic of our main scene, which is the very first thing that runs. So that code was running before our car had actually moved, which means that we were getting an old transform. We were getting last frames transform. While using the remote transform logic, I think that one's actually copying it. That one's copying it in the process function, I think. So that will be copying it right before we're rendering. Now, I think that will cause us problems if the physics engine is running in a separate thread. I think the only way to make sure this works absolutely without fault is if we would put this logic in the physics process step of our vehicle body, because that is the physics process step that is actually moving the physics body, and after that, that gets handled first, and then our bit of logic runs, which can copy the location, and that would make sure that if we are running the physics logic in a separate thread, we would still be getting the right position update. I'm guessing. when we're dealing with multi-threading, it all gets a little bit hairy. So yeah, that's always an interesting thing. Yeah, you could do deformation with a vertex shader, but what you would often see if they do damage on cars, either they have the car or parts of the car meshes. So when we look at a car, where's a car? Car. So when we're looking at a car, you would have different versions of each mesh, each with different levels of damage, and either you do use a vertex shader to what's the right now word for it? Morph from one to the other so that it's looks a little bit smoother. But most games actually they just replace the mesh from with one with more damage, because usually damage is created within a frame anyway. And when you're sitting inside of the car, because right now we don't have any exterior cameras, which is something that probably will only support in the desktop version and not in the VR version. Doesn't make sense in the VR version. But if you have damage, you don't see much from inside of the car. But there's different techniques. There are indeed techniques where you deform the car's mesh itself with the vertex shader, or like I said, the most common implementation is to have damaged versions of your mesh, and then usually you would have your mesh broken up in parts. So you would have the front part of your car being a separate mesh, the middle part of your car being a separate mesh, and the left being separate, right being separate, back being separate. Obviously, it will be a little bit different for a KDRM type car or a Lotus 7 or whatever. I guess it's a Lotus 7 because there's a 7 on the front. It'll be a bit different because you've got the fenders that would be, that could break separately and stuff like that. While with a normal sedan type car or hatchback or whatever, you would have different parts of the car get damaged in different ways. But you would generally, you would have each section of the car, you would have different meshes for each section. So you would have, for instance, here, let's say the fender, you would have the fender in good condition like here, and then you would have one with minor damage, and then you would have one with more damage, and you would have one where the thing is broken off or something like that. And you would be keeping track of how much damage each part of the car. So when you look at a lot of games, you have a health bar. You have in your car or in your object, you have a variable called health. In this case, you would be tracking that for each part of the car, and you would basically say if the health is above 90, show the undamaged mesh. Is it between 75 and 90, show a little bit of damage. Is it between 50 and 75, show a lot more damage. If it's below, between 25 and 50, show, the lower that value goes, the more damaged version of that mesh you show. And then depending on when you crash into things, it's then a matter of figuring out, okay, did I crash at the front, did I crash at the back, did I crash at the side, which mesh is closest to that impact point. That's the mesh that I decrease my health and therefore increase the damaged mesh that I'm showing. Yeah, you could do it through shape keys. That works. Again, it's whether you want to actually show more when something gets damaged, or whether it's enough to just crumple the things that you have and then indeed work with shape keys. I could imagine that if you get to the maximum damage, for instance, for the hood, you would actually want to remove the hood, and all of a sudden there's the engine, right? You want to actually be able to see the engine. And you would actually want to see that thing fly off. So you would have extra logic there that when the health of the hood of your car goes below 25, you actually detach, or you spawn in the hood as a separate object, as just a physics body that just flies off the car and goes. So there's so many different ways of doing that. We were talking about the steering. So the important bit here is that our steering wheel over here is a separate object. Now, lucky enough for me, is this my local? No, that one. Lucky enough for me, the steering wheel is nicely centered and positioned so that if I rotate the steering wheel around its local axes, it actually does exactly what I want. Not all things will do that, and if that's not set up properly, you'll have to do a little bit more trickery. But all I'm doing, if I can find it, where is my steering logic? Steer value, yeah. Steering angle. Yeah, here we go. So I'm just updating that angle position based on my controller input. That's all I'm doing. So the same controller input that I'm using to actually steer the car, I'm also applying to my steering wheel. So basically, it's a one-on-one thing, right? It's there's nothing special about this, but when there, if I'm changing my steering wheel, oh, I'm doing a lerp. I didn't realize that, but you can see that the wheels turn because that's part of the vehicle body logic, but also the steering wheel turns. Now, obviously, in our desktop version, my camera, maybe I need to put my camera a little lower so that we see a little bit more of our interior. Then again, you know, I don't want to see too much of it, so I'm kind of happy about it being where it is. Obviously, one of the things that I do want to do is eventually animate the the dials and actually get some speedos going. Not quite sure if that's something we'll get to today. So here my car is disappearing again, and I have no idea why it's doing that. I don't think there is any logic in here that that should make the car disappear. Well, that's the lights. That's fine. That's the only places where I am changing the visibility of something. So I'm not quite sure why that's happening. That's another mystery to find out. But I actually want to work on some other stuff first. And again, like I said, I had all this logic before, and I lost it. So we're going to have to reinvent the wheel today. Yeah, the collision system would definitely be the tricky bit. Figuring out where you hit something and which part of the car to damage is there are some things in the physics engine that aren't communicated well. So yeah, that is definitely something where I think Godot could use some improvement. But again, without it actually implementing it, I can only theorize about how you would do it. Obviously, I've had some logic in my physics tutorial series, and again, there I did run into the problem that some things you can, certain interactions between objects, you actually get the location and information of where you're hitting something, and with certain other things you didn't. I remember that the biggest problem that I had was figuring out in which direction and with how much force one object is hitting something so that it could get the explosions right and that sort of stuff. I think normally when you do have two... No, because that's the thing. If you have two rigid bodies colliding, you can get your signal, which signals you've collided, but you don't actually get information about that collision. It's annoying. And I think you could get it if you query the physics engine directly, but without that, it's not giving you that info, which is I think is a shortcoming of the physics engine in Godot. So I know that that they're talking about revamping the physics engine for Godot 4. I think there's actually talk about hiring someone to work on the physics engine, which would be really cool. So maybe that's functionality that will come. Who knows? Oh, so you're actually deforming the mesh just as you hit things, not between predefined states. Yeah, that works. I would always work with offsets at that point in time, so that you can just turn the offset spec to 0. Anyway, so the whole idea here originally was, now I remember, was for this car script to be reusable for any vehicle, and then just have us further configure stuff, which is pretty doable. So we can probably keep that going and work with that. Okay. So the thing that I really wanted to implement is to actually work with gears. That's something that I've been asked many times. How do you do gear ratios for an implementation like this, where we want to go between the gears that the car runs in? Now, one of the problems that we have with vehicle body is that the vehicle body has got no idea, right? All we do with our vehicle body is, if we look at our rigid body, our vehicle body inputs, is we give it an engine force, we give it a braking force, and we're giving a steering input. The steering input simply moving the steering wheels, or the wheels that have steering. And that reminds me, I just want to double check this per wheel motion. We're not doing actually per wheel motion, but I do want to check if the traction is set properly. So that's right front, so that's steering, no traction. And then the left rear is traction, no steering. And front is no traction, steering. Okay, perfect. So whichever wheels have got steering on, they are oriented based on our steering input, and that controls the direction that the car is moving in. And the other thing is the engine force is pushing the car forward, which is basically I think that the force is applied to each wheel that has traction, or the force divided by the number of traction wheels, and that's sort of meant to push the car forward. While I think with brake, it is a braking force on all 4 wheels, because you can brake on all 4 unless a wheel loses traction. Now, in there is a problem that if there is no traction, so the car is off the ground, Godot basically stops. It stops doing anything. So, yeah, that's one of the things where the simulation kind of breaks, and that is something that I am not really that worried about at this point in time. We're not going to go through or that far through what we want to do. All right, now one thing that is nice is for now I'm just going to stick to controller input and just worry about doing this with controller, which means that I've got my gas on here, I've got my brake on here, and I'm probably going to be using our little L1 and L2 buttons to flip through the gears. And again, I'm not worrying about VR at the moment either, so we can dump some things on screen that help us investigate whether we're doing the right thing. All right. So right now we have a max engine force of 150, whatever that means. I honestly couldn't tell you how that is applied as far as our car is concerned. So, okay. Let's start with getting some data in here. Let's just start there and work our way up. Basically, just to start to explain how we're going to approach this, is we're going to create a feedback loop, right? So our car is moving at a certain speed. Again, we don't actually have any information other than the speed at which the car is moving. and that speed that the car is moving, we're going to assume, if the car has got grip, that is really the speed at which we're moving forward. And therefore, the whole drivetrain does its thing, and all the calculations that we're doing are sound. Now, if the car breaks traction, then the engine speed and the wheels might be spinning, or it might be flying through the air, and the wheels might be doing whatever they want to do. At that point in time, the speed of the car, the movement speed of the car, has got nothing to do with what the drivetrain is doing. And that's where our first version of our implementation is going to break. So eventually we will add some logic in that detects whether the car is off the ground or not, or whether it's lost traction or not. As long as we've got traction, we do our normal calculation. We assume that everything's working the way that it should be. So the thing that we're going to be working on right now. But if we have lost traction, we'll do something special. Now, the same thing applies to when you are when you are not in gear, so if you're in neutral. Because obviously, in neutral, you can rev the engine as much as you want. The car is not moving. And our current logic is going to be based on the speed of the car moving. So, again, that's basically, if you're in neutral, you would treat the car the same as when it is when it's lost traction. So I'm not sure if that's something that we will handle tonight. For tonight, I just want to have a look at, okay, I want this car to run through gears, and I want it to react properly with that. All right. So the things that we have here right now is our max engine force, which is going to change. Our max brake force, that I'm fine with, because that's something that we're going to keep working with. Our max steering angle, which is currently, I guess, in radians. It's definitely not degrees. So that might be something that we will clean up at some point in time. Steer speed is how quickly we turn our wheel depending on our input. Which again, if we actually have a steering wheel, I don't have a steering wheel, but if we have a steering wheel to play with, that speed should be 0. It should be immediate. It's when we are using a controller and we're going full left on our stick. We don't want our steering wheel to go full left. We actually want to turn towards our max steering. And that gives a little bit more control over things. The same with the keyboard as well. If you press left to turn left, you don't want it to be immediate full lock to the left. You want the steering wheel to turn so that the player has got some master control over it. That's why we've got a steer speed there. I guess that the steer speed on keyboard and joystick I've made separate. I'm not sure. No idea what I'm doing with steering multiplier. Again, I wrote this logic quite a long time ago. I'm not even sure that is still used. Steer speed, steer target, steer angle. Oh, that is on the inputs, on the joystick inputs. Okay. Up, down, left, right. Yeah, because I'm getting my steering value from my joystick axis, and I'm doing times the steering multiplier. That's just if I need to invert the direction of. So that's really 1 or -1. In this case, -1. So obviously, if you go left, you get a negative number, but I need to have a positive rotation. I'm guessing. Is that correct with this as well? Yeah, left is positive, right is negative in steering. So that's why I'm inverting that. When I look at this, I don't actually think that should be a value. That should just be. I should actually make sure this logic works with the values flipped around. Anyway, that's not something that I worry. I actually don't even want to touch the steering tonight, so I'm happy with how the steering works. So the same with the joystick throttle and joystick brake. So that's the other thing here is we've just got those things hard-coded on numbers. We should actually use enumeration there so that we can identify which button it is. Or better yet, is actually start using our action system to actually put the joystick values in there. So that's something that I might do at some point, because also with the input mapping we can do some more setup stuff. I am not using the Vim plugin for the Godot editor. I'm pretty happy with editing my code in the Godot editor. But I think what's the name? I think Nathan from GG Quest. He uses Vim, and I think he's done a tutorial series on his YouTube channel about setting up Vim with Godot. Could be mistaken, but I think that's one of the things that he did at some point. So check that out, because I think he's got that working. All right. I don't have my browser open. Sorry, I got my caps lock on. Let's turn my caps lock off. All right. What the hell? Okay, so an original Lotus 7. Okay, so that's the original Lotus 7, the hand-built cars from Lotus. Built in the late 50s. Let's see. Only has 3 gears. It's a 3-speed manual. Okay, I'm not going to use that. I'm actually going to go and look at Caterham. Okay, let's have a look, because I know that this is based on a Caterham. I'm probably mispronouncing Caterham. I don't know. Because I want the here we go, the CSR. That's the one that we're doing, because it has CSR on the number plate. So I'm pretty sure that the guy who modeled this one, I can't remember where I got this from, Turbo Squid, I think. I think it was one of the free downloads there. But yeah, it was based on the CSR. So if I'm not mistaken, this thing has got a 6-speed gears. There we go. So here's all our gear ratios. And the reason I wanted to look this up is actually I want to use this information in what we're doing. We're just going to use the 260 model. That's fine enough by me. This has got a 6-speed gearbox. So we're going to build our logic based on a 6-gear speed gearbox. Obviously, if we only want to support 3 gears or 4 gears or 5 gears, we're just going to leave the last ratio 0, and we're going to make sure that we can't actually shift to those. So let's go and speed and drive selection, drive direction. So let's go and all right. So we already have our current speed. That's pretty cool. Gears. So we're going to start with our ratios. Actually, we can make this a what do you call it? We can make this an array. If I could only remember how the definition works. Okay. Gear ratios. Two 2.69, 101, 59, 32, 13, 1. Okay, so we don't have a reverse gear ratio on this. That's interesting. So we need to figure out what our reverse gear eventually will be if we want to implement reverse. I'm actually going to put that in there. Reverse ratio. And I'm going to just put that to 2.5 right now. Reverse is usually somewhere between first and second gear, but then obviously in reverse. And we also need to, actually let's call it final drive. We also need our final drive. So this is the gear ratio of your differential at the end. All right. So, invalid. That's probably, is that just like this? I think it is. Does that work? Yeah, that works. Cool. All right. So I don't know if, because I put this arrow in here, if it now automatically classes that as a what you call it? Why do I always keep forgetting this? If it classes it as a floating point array, if that's enough. But yeah, I'd like to type it properly as a floating point thing. But yeah, now this is actually better because now we know how many gears we have. If we have a car where we don't have 6 gears, we only have 4 gears, we can change the size to 4 and we can put those in. We have our reverse ratio, we have our final drive, and that's all good. So the next thing that we want to do is we want to set our no, actually, let's put it the other way. So our selected gear. So 0 is going to be, so -1 is going to be reverse. 0 is neutral. Neutral. Thank you, Baz. And is going to be gear. I'm actually going to default this to 1 for now, even though that is wrong. Because we don't have a working gear system yet. So we're going to play around with that some more in a minute. All right. So, all right. Now the next thing that I want to do, just for now, we're going to throw a label on this thing. There we go. Do I have my fonts in here? Do I have my fonts in here? Yes, I do. All right. Fonts. Code. Assets. Fonts. 24. There we go. Obviously, that's just for debug info. We're going to be removing that. What I want to do right now, that's physics process. Very good. Okay. So what we're going to be doing here is we're going to create our process function. And we're just going to put some info in there. And the first thing that we're going to do is we're going to put our speed in there. Okay, MPS is meters per second in this case. Where we actually need to see how are we calculating that? Where are we calculating that? We're calculating that at the beginning, and we're doing that based on our actual position change between our current frame and our last frame. That's really cool. So our info is speed plus str. There we go. So let's just start with that, and that means that we can now do info.text is info. I'm not going to worry about the rest of the gears at this moment. I just want to print that out on screen so that we can see how fast we're moving. There we go. Boom. So we're going faster and faster. I think this thing is going to have an unlimited top speed at the moment. Wow. Not quite sure how I'm limiting that. Again, our body is disappearing, and I have no idea why. That's definitely something to be investigated, but not right now. All right, this track is definitely too small to drive at speeds at. I'm actually surprised that I'm not getting any higher than 80 kph at the moment. So one of the things that I actually want to do, and I think that's why I put that test in here. So what do we have in our test scene? That's just a empty. Actually, I guess I didn't do anything with that yet. So if we compare that to that track here. That's coming from our base world. Oh, I don't have a base world scene. I just have a base world script. That's interesting. That's definitely something that I want to change. But not now. So let's go and actually set up a test scene, because the thing that I wanted to do here. Did we give that any sort of special name? No, we just have that set up like that. Okay. That's interesting, because actually that really should be oh, that's fine. So if we go in here, oh, it's that one. Where's my test? Oh, that doesn't have a script yet. Okay, cool. So that slowdown that you see there is because that CSG gets recalculated every time that we open up that tab. It's kind of annoying. So for now, I am just going to go and copy this over and put this in here. Because I want to do the same thing. It also means that I need to have my car in here. And again, there are definitely better ways to do that, which also means that I need my remote transform in there. What did I call my... Oh, that was not over there. Let's actually just look at our script, what we call that thing. Driver, okay. Driver, there we go. So this guy actually needs to be... Can I just copy that from here? Driver. Transform. Is there a way to just copy the transform? That's minus 180. I hate to go back and forth between these two scenes. There we go. No, not car. Track. Seeing that it takes so long to open this thing. Well, for now, we'll just copy it. I'm pretty sure there's a faster way to do this. But again, I need to really make constructs for this. So that, yeah, we know we have that always in the same position. So, okay, so we got our driver, we got our car. Boom, our car's in our scene. Obviously, we don't have anything in this scene yet. It's using our default environment. That's cool. So what I want to do here is a static body. Put it at the front here, ground. And I want to add a mesh instance here. And that is going to be a plane mesh. And that plane mesh is going to be really big. There we go. Maybe subdivide a bit. I don't know if that matters, but I'll do it anyway. Let's see if I have a nice floor material. I will just use a terrain texture. Do I really want that? That looks ugly. Do I have other materials? That's just a JPEG. That's not got anything with it. You know what? We'll just use that for now so that we at least have something that we're driving on. What is that doing? Sunwise. Guess that's just a directional lights. Let's repeat that here as well. We need to have, before I forget, we need to have a collision shape here. So all that I want to create here is I want to create a nice open space where we can test whether our car works. And I guess, again, this This ground doesn't make any sense for that. Eventually, we'll turn this test scene into, I don't know, a parking lot or something like that. That would actually be a cool idea. Just have a big parking lot, and we can do some crazy stuff there just to test. Anyway, box shape needs to be nice and large, and move that down. I think that's -1. So our car should now be able to drive on that. That's good. Let's go and put our sun in here. Here we go. But before we do that, I do want to use my world environment just for now. Just so that we have our... Okay, so that is actually something that I'm not happy about, because I'm using my default there and I didn't see it. That means that our default isn't actually set in our settings here. So somewhere over here, environment, we don't have a default environment set. There we go. All right, perfect. That's all I wanted. So now I'm going to use a little trick that I learned, which is that we orientate this like this. Boom. Actually, let's put that to local. There we go. And that's too high because we want to make sure. Oh. There we go. Now our sun aligns with that. I also want to cast a shadow. Boom. Shadow for a car. Cool. Not that we see a shadow for a car, but at least we got lights. Alright. Now the last thing that we need to do is go here. And then instead of loading our track here, well, we'll see it. I did it the first time, but like I said, I lost my I lost my test project. So we'll see how far we're gonna get with that tonight. How are we on time? We're pretty okay on time. Alrighty, let's go. Cool. Except for the fact that I can't drive anymore. Why is my car not driving? I don't know. Actually gonna go and dump it in a bit, just in case it's somehow stuck in the ground. Okay, something's definitely not linked up correctly right now. Why not? Let's see if there's anything different here. Mode, rigid, mass. Yeah. Okay. That's all the same. Okay, what is the difference between our test scene here? Alright, did I do anything with physics layers here? I don't think so. Nope. So everything should just be in normal physics layers. Yep. Did I do anything here? Because we didn't change anything yet with the logic, so that's all good. Oh, hold on. So, no, that's all there. Okay. That's all I know. That's set there. I didn't change anything else. Something might be bigger. All fine, so those are all warnings. It shouldn't be a problem. Those are all standard. Okay. Oops. That's not what I had in mind. This is weird. Why would that suddenly stop our car's physics working? I don't do anything weird with this. It's loading my test scene. And the weird thing is, you can see that the steering wheel and the fenders are moving, but the wheels are not moving. The wheels are supposed to move based on the logic. Oh, right, come on. Let's go and have a look at it like this. So I'm going to not make it full screen. And instead, I'm going to check a remote here. We're going to go into our world scene, test scene. Here's a car. So steering input is definitely going in. You can see, as I'm changing my thing, we can see that that is moving. But we still see that our wheels are not. I'm actually getting my engine force to 140, but nothing is happening. So we definitely know that we're that our code is working. So why is my... Because it's set to sleeping. Okay, is that it? It's back to sleeping. So if I turn can sleep off, there we go. Oops, can sleep off. Okay, so my steering wheel is now working properly, but I still can't move. Why? Why? What am I? Let's turn can sleep off because I actually don't really care about can sleep. Actually, I want to turn that even off on my car because this is our main physics body, so we never want that guy to go to sleep. Basically, once an object goes to sleep, it's the physics engine stops processing it. But now, why is our car? That's all fine. What is the difference between this? So this is static body, so I have no idea why we would have those things. Alright. Let's go and look at our track scene one more time. I hate loading this thing because it takes so long to get the path in there. So we're not actually doing anything different here, that's fine. But what about the track itself? That's just a curve, okay. Oh, I didn't want to go to the script. I wanted to go to the subscene. Just want to see if there's anything different that we've got in here. Oh, that's using the CSG collision shape. So that's just doing a static body that way. That shouldn't be any different from what I'm doing here. So why can't my car drive on our ground? Unless, let's go 1-1. Yep. Oh, what? Really? Okay, how the hell did that happen? We must have moved it somehow. But we were stuck inside of our collision shape. So I'm not quite sure how I managed to move our collision shape like that. But I am guessing that that was our problem. I'm guessing our car was stuck inside of our collision shape. And therefore not doing anything. No, still not working. I am mystified. So that was not it. Did I still have my car off the ground? Ever so slightly, so I want to move it a bit above ground so we can actually see it fall down. Alright, cool. Well, it's resting on top, but it's still not driving. I don't get this. I'm just duplicating that because that will allow me to move this outside. Save. I just want to see if there's anything on the outside that we can see. Okay, so our car drops straight through. We've lost some settings somewhere. Alright, what am I doing here? What is different? Between these. Shape. Okay. I'm gonna do something really weird. Change type. Feature body. Clutching at straws at the moment. No, still goes straight through. What has changed? Okay, let's change that back to a static body because obviously that doesn't make a difference. And that is therefore not our problem. Let's make this just small. Let's see if it's something that it just can't deal with. That's all fine too. Let's actually go back to our car. That's doing nothing. Our car is just on, it's all collision layer 1. I'm not doing anything with the collision layers. Okay, let's do something different. That's even really more weird. But like I said, I'm clutching at straws right now. So we're going to actually change that to a spatial. And now I'm going to add a CSG box. And we're going to make that box 5,000 wide. And actually, this needs to be 10,000 because geometry, no, transform, -1. So that's now on the floor. Use as a collision shape. You are no longer my collision shape. And we don't want to see it. Because even though we're hiding it, it's still a valid collision shape. Beats me. Absolutely. So, static bodies are not working properly? That doesn't make any sense because the CSG object is basically creating a static body behind the scenes. So, unless I did something with that static body without realizing it, does it need to have a physics material, maybe? I'm just going to hide that guy, and I'm going to turn use collisions off and change this guy back. Now, obviously, if I can't make this work, then we're just going to use the CSG mesh. So it's not really a big deal. But I want to know why this guy doesn't work. So collisions in the right layers. Perfect. And now suddenly it works. Is that because I still have this guy in here? Goodbye. Did I accidentally untick something? It's working now. So I have no idea. But I'm not complaining, it's working now, so super weird. Alright. Bouncy car. Anyway, the reason I wanted to try this out was... Whoa! Okay, we went off the edge of our... Alright, that was a fast 10 kilometers. Alright. So oh yeah, because I made that smaller again for testing. That's right. So let's make that the full size again. Now we should be able to drive a bit further. But it looks like in our current settings, the maximum speed of a car is 80 kilometers an hour. Oh, and it stopped working again. So maybe it was our collision shape and we just didn't test it well enough. Really? I'm not going to go full screen. Okay. We can't make our collision shape bigger? Since when is there a maximum size on our collision matches? That's new. Beats me. Look at that. So the size of our collision shape is somehow affecting our collisions. That's new. Let's see if let's see if adding a physics material makes any difference here. No. That is really weird. I don't know what's changed there. That makes no sense. It's a static body. Why would the size of the collision shape affect how the static body behaves? Yeah, and I'm starting to think that this is definitely a an engine bug. That said, we're just gonna use our workaround, and I have no idea why a CSG box, unless we didn't make this one big enough just now. Oh no, that didn't need to be 2. There we go. Transform -1. Gotta be a collision shape. Don't show it. Yeah. So somehow on the CSG box, the properties of a static body are different. Don't ask me why. But the only reason I'm doing this is I just want to see what sort of speed we can go up to. With just our standard value here. Whoa! Okay, so obviously if we skid out, things get wild, but that's okay. Anyway, we've got a test scene. That's really all that I care about. I really didn't care about any of the other stuff. That was just a unnecessary distraction that we just had. But we have some info now on screen about how fast we're going. I'm more than happy about that. The fact that we can slide a bit really doesn't matter at this point in time. We need to start working on our... actually, I'm happy enough to close that now. We need to start working on this. Now, our first step is that we now know how fast our car is moving. We know our gear ratios. So we're going to work our way backwards to figure out what our RPM is. So, in our car, where is that all? So just like we have over here, we gotta get speed kph. We're gonna get a function here is func get engine RPM. All right. And now we're simply going to go and work backwards. Now, we have our current speed in meters per second. So the first thing that we want to calculate is our wheel rotation speed. And we're going to start with our current speed in meters per second moving forward. Why do we have that? Yeah, because I'm not finished with it yet. And what we now need to do is we need to divide that by the circumference of our wheel. Because our speed that we're moving forward divided by the circumference of our wheel gives us how fast our wheel rotates. So we already have meters per second. So we need to get our wheel rotation or size, and we're simply going to get that from our, we don't really care about whether we're using our left or our right wheel, as long as we got a rear wheel, because they're going to be the same size, right? So we just pick one, and what we want to know is we want to know our radius, and we want to use that. So again, we're here we are going to use the assumption that we have our right rear wheel as a hard-coded thing, but at some point in time, obviously, either we need to make sure that that's always called that way. Wheel. Okay, I've got no idea how you spell circumference. Wheel size, whatever. So yeah, obviously at some point in time we might need to figure that one out. Radius. Wheel radius, thank you. All right, so I knew this once. I'm spelling this absolutely wrong. Circumference. But let Google figure it out. 2 pi r. I should have known that. 2 times pi times our wheel radius. There we go. So we're going to divide that by our wheel size. So now we know our wheel rotation speed. Now, I'm going to start by returning that just so that we can see. Actually, let's just do this. RPM. Let's actually. Have that input. Hey, Rodzilla, how you going? Nice of you to join again. We're doing good. We're starting to figure out how this all comes to be. This is the other thing that I always forget. Godot format float to string. Format strings. Okay. It's a percentage. There we go. Let's see that's percent. Point to float. Correctly, yep. And we give it an array here if I could remember correctly. Speed, that's RPM. And of course, we don't have our RPM yet. We're not even close. But I want to just get the value that we've calculated so far. I need to make that full screen tick box on by default. All right. So again, our RPM doesn't make sense at this point in time. First of all, because we're not calculating it right. But second of all, because it's directly associated with our. That's right. Okay, so let's keep calculating. So we now have our wheel rotation speed. Now we're going to divide it by our final drive to get our drive shaft speed. Final drive. There we go. All right. All right. So here is where it gets interesting. First of all, if selected gear 0, we're in neutral. For now, we're just going to return 0. We're going to make a if we're in neutral or we've lost traction, use our previous RPM. So if we don't have traction or we're in neutral, we're going to eventually start storing the last RPM that we calculated before we got into this scenario. And then we just basically, based on what the user is doing with their throttle input, we're going to play around with the engine RPM and have some fun with that. So that also means that if we then get traction again, or we switch gears, the RPM that we're calculating here, we're going to be lerping with that last RPM that we calculated. So that if you're in neutral and you rev your engine to say 3,000 RPM and then you shift to the first gear, that's how we put power to the road, and we're going to not immediately go back to 0 because now we're only started moving. We're actually going to be using that RPM and using this input. For now, we're not going to bother with that. For now, we're going to exactly again, because we're at that point in time, we are we're basically what's the right word? What am I thinking of? We're basically emulating our clutch. That's really what we're doing. Okay. So now we need to divide our drive shaft speed with our ratio. But here we need to know if selected gear is -1. Double is -1. Then RPM is RPM divided by the negative, the reverse ratio. So in this case, we don't care that this one is negative, or we're expecting it to be negative. So we want a positive number. If you're reversing out at 1,000 RPM, you're reversing out at 1,000 RPM. That is going to be important when we feed this back into our throttle logic. Else, we're going to say RPM is RPM divided by gear ratios, selected gear, and this is counting from 0, so we need to do -1. All right. So we're in gear 1. So we should get some crazy RPM numbers the moment we get up to speed. But hey, we're starting, right? So let's see. Okay, we're not. Okay, and this is the other one. Yeah, RPM is by minute. We have meters per second. So this is number of rotations per second. We actually want to do that per minute. So now we actually have RPS, basically. So we're going to add 60 there to get that per minute. Actually, no. We're going to add it over here. 60 times there. So let's see. Are we now getting? I might be doing the gear ratios the wrong way because I'm dividing. I might need to be multiplying. I'm thinking I'm doing it the wrong way around. Yeah, that's interesting. Okay. Yeah, it should be the other way around. So we're going to do times final drive, and then times ratio, and also here times ratio. Let's see. I think it's still on the low side. Because this way we can do everything still in our first gear. That doesn't make any sense. Okay, what are we missing here? Meters per second, that's how fast we're moving. Times 60, we get meters per minute. Divided by our radius is going to... Hi, Declan, how you going? Nice of you to join. Okay, where am I going wrong in my... Actually, I'm just going to do that. It's a bit overdone. I'm just going to here, drive, shaft, speed. I'm going to do it like that. Yeah, took that by our radius. So, let me get that. So that's how fast our wheels are spinning. Okay, the other thing actually is I want to do this 0.0 because that's no point to have that in more detail. So we're already going 30 miles per hour, or kilometers per hour. Am I just thinking this the wrong way through? Can we really go 6,000 RPM and already drive 80 in first gear? Does that make sense? Maybe that does make sense. I don't know. Or are we calculating our... Yeah, meters, so that's divided by 1,000 to get kilometers per second. And that's 3,600 kilometers in an hour. Okay, are we calculating our... Taking the physics engine properly? Yeah, meters per second. That looks the way that I'm expecting it to look. The only thing I can think of is that gear ratio, because this is a very low gear ratio. Because that's the thing that I find interesting, is how low that gear ratio starts. Only 2.6. Look at that one being 3.36. So maybe the engine is powerful enough to do that. What's the max RPM of this thing? Does it say somewhere? Well, max power is at 7,500 RPM, 260 brake horsepower. Max torque at 6,200. So we're not going to do that very accurately, but we're going to approximate that. Doesn't say max RPM though. That's the maximum power. Now after that it falls off, but that's not the maximum RPM that we can do. It's a bit of a shame that it doesn't show us how far we can go. Anyway, so assuming this is correct, and we have the correct RPM value here, which I don't fully debate. I just want to put my gear in here as well. I'm going to go put our gear in. Actually, I don't even care about our speed being more than that. Okay. Boom, boom. All right. Yeah. So in gear 1, we're going that fast. All right, so let's go and make our bumpers actually do the gear change. And again, we're not actually doing anything with the engine yet, so the gear is purely giving us information, and the moment that we just keep accelerating, you know, we're at some point we're getting crazy high RPM numbers, which is fine. Do I want that logic in here? Why not? So I'm going to make that in my project settings, in my input map. We're just going to add a new action called shift up, add, and we're going to do a joy button, and the button that we want is our R1. So this one. Okay, and we also need to have a shift down button, and here we're going to get our L1. Okay, close. Okay, so in our process, let's do that first, why not? If action, no, input action, just pressed shift down and selected gear is bigger than -1. And we do selected gear is selected gear -1. So we go back down 1. Let's copy that. So here we're going to go shift up. And here, as long as our selected gear is smaller than gear ratio size, we're going to increase our gear. There we go. And again, this allows us to change gears. We're not, oh, wait, is that giving us an error? Why? Oh, because I'm missing a space here. There we go. All right. So this allows us to change gears even though our gears don't do anything. So when I'm moving, obviously if I go to neutral, we're going to put our RPM in 0 because we don't have anything. I can still accelerate because we're not doing anything with that yet. It's fine. So I can put it in minus in reverse even though I'm still going forward. Because we're not actually doing anything with direction. And obviously we don't have any sort of protection at this point in time. If I keep going faster and faster in gear 6, at some point in time we would get to our maximum speed, which is fine. But anyway, so all we've done right now is we created one side of our feedback loop. Depending on the speed that we're going and depending on the gear that we're in, we're calculating backwards to what our RPM of our engine is at this point in time. All right, so that's one side. You know, we're not worried about how we're accelerating. We're not worried about how the gears affect our acceleration. All we're worried about right now is we got an engine. How fast is our engine turning? Or how fast should our engine be turning to maintain this speed? It also means that we haven't got any logic in here what happens if we shift back a gear while we're already at top RPM and you normally blow up our engine. We're not worried about that at all at this point in time. That's all fine. All that we're worried about right now is if we're going at this speed with our current gear selection, how fast is our engine turning? That's one half of our feedback loop. How fast are we going? What's the engine speed? Now we're going to work the other way around and we're going to say, okay, at that engine speed, what is the maximum power our engine will output? And then we're going to apply our gears to figure out what's the power on our wheels at that point in time. So, with our RPM in hand, we're now going to affect our throttle. So when we look at our throttle, so obviously it is reversed in this case. We're not going to implement anymore in that way. Because that used to be part of our braking system. That's now part of our gear system. So let's go and remove that. That will eventually come out of what gear we're in. And that'll be quite fun because, yeah, we're gonna... All right. All right. Okay. Great. Why am I using that? What am I using that for? Sorry, I'm trying to piece together again. What did I build this originally for like this? Oh, that was just to make sure that... Okay, so we're going to get rid of that as well. We're going to get rid of this whole thing over here. All right. So, okay, so here is the swap, but actually I'm not going to implement that the way that that I did that. Okay. So I'm going to keep this in there. All right. So here we're going to change the way that our throttle valve is going to be working. And I'm just moving this out of the way for a minute, because we're going to be changing that. Oh, this can always be current, no, gear, selected gear. There we go. So if we have our reverse selected, we're going to get our reverse lights on. Very cool. And here we're going to have our brake value is bigger than 0. Then we're going to be doing that. Okay, cool. So here, same thing. Brake value is going to become... Oh, that's why I wanted to keep that separate. No, I don't actually care that, because the max brake force is just going to give it max. It's still going to be bigger than 0.1. So that's just going to be our brake value. Okay. So the thing that I want to change here is if selected gear. No, actually, why don't I make that throttle valve smaller than 0? Else we shall do this. In this case, if we're trying to reverse, we're actually not going to do an engine force. Instead, we're going to subtract our throttle valve. Remember, our throttle valve is negative, so we're actually adding our reverse to our brake. It's a bit of a cheat, but I'm going to assume that someone isn't going to be braking in that way. Now, the other thing which is interesting is that if we are reversing and we want to brake, then we probably actually want to give an engine force. So we might actually need to do a similar thing here, where where our brake is either going to be added to our engine force or to our brake, depending on whether we're moving forward or whether we're moving backwards. I'm guessing. That's something to figure out at some point. All right. So our brake value I'm happy with, but our engine value we're going to change. And the way that we're going to change this is, depending on our RPM of our engine, we're going to create a power curve. So if our engine isn't turning, we're also not going to be making any power. While if our engine is at 3000 RPM, we're going to go towards our maximum power. At some point, we're going to top out on our power. But that's the maximum power our engine can produce at that value. So basically, we're going to go and change our max engine force based on our power curve. So we're going to have to go and introduce that here. Okay. We're going to add that in here. I'm going to move you over there. There we go. And now we're going to add our, so we need our RPM here. RPM is engine RPM. There we go. Now we need to have a max RPM. So what's the maximum RPM of our engine? There we're going. I actually want to go over here. Export var max engine RPM. So let's, for argument's sake, say our maximum RPM is 8000. There we go. Where are we? So I'm actually going to go and put that into this. So that's no longer RPM. It's now RPM unified between 0 and 1. 0 if the engine isn't turning. 1 if the engine is turning at max power. And we're going to clamp this guy. And I'm actually not going to clamp it all the way down to 0. I'm going to clamp that at 0.1. And the reason that I'm doing that is if we're standing still and our engine doesn't have any RPM, our power curve is going to be at 0. We would never be able to move. Remember, a normal engine will run idle at 1,000 RPM. You'll have your clutch in, and when you want to drive away, you're actually going to increase your speed before you switch. Now, we're going to be implementing that at some point in time, but not now. I do want to do that, like I said before, is that if you're in neutral, that we will just throttle the RPM up and down depending on our pedals, and then calculate this backwards. So now that we have our RPM, we want to enter our RPM into a curve, into a power curve, to see how much power we are able to produce at that RPM. Remember, we're interested in our maximum power, which we're going to be calculating on our, or multiplying with our actual throttle input. So let's add a curve in for that. Where am I with my gear ratios? So I want to make that export var power curve. We're going to default that to null, and that's going to become a curve. There we go. And that one we're going to nicely set up over here for our default power curve. New curve, boom. So 0 is no power, 1 is max power, 0 is no RPM, 1 is max RPM, in this case 8,000 RPM, and we can draw in a power curve. So, that point. So we're going to start off almost at 0. Then I want this guy to, actually, we're going to go and ramp that all the way up to somewhere over here. And we're going to ramp that down again over there. So that's just, a basic power curve. I might actually add one more over here and just make that a bit smoother. Maybe do it a bit more like this. I don't want to go over 1. So no, this one actually I do. There we go. Again, whether this is a representative power curve, I don't care. We can play with this as much as we want. We just have a power curve. So this is going to give us the power at our engine. But obviously, through our gear ratios in reverse, our power is going to lessen. So we're going to apply our gear ratios in reverse. Now, at that point in time, that max engine force of 150 is probably absolutely nonsense. Much too low, because we're going to be stepping it down quite a bit. So we're going to have to make that higher again. Anyway, so let's go and put our power curve in. So in this case, our the fact that our reverse gear is negative is great. So actually, you know what? I am going to go and move that over here. Keep that in there. And instead, here we're going to get a curve. No, engine. What did I call that? Power curve? Oh, what the? Power curve. There we go. How do we get a value out of a curve again? I've done that so many times and I always forget. Curve. There we go. Curve. Interpolate. Actually, let's get our interpolate baked. RPM. So there we go. We got a max power for that RPM, which of course eventually is going to be multiplied by our max engine force. And now we need to go and check out our gear. So if our selected gear is our reverse gear, we're simply going to say max power is max power divided by let me see, is that the other way? Is that way around? Is that the other way around? because the lower your gear, the more power we get to the wheels. Which is the times. Reverse ratio. So that is going to be a negative number, which is going to allow us to reverse. Obviously, if I select the gear is 0, our max power is going to be 0 because we're in neutral. We're not putting any power to the wheels. And else our max power is max power. Okay, so with our 150 engine max engine force, because this is now going to actually go up instead of down, that probably needs to be a lower number. But that's okay. Now the other thing is we can multiply our final gear here, but that's really no point because it's a constant, and that's either going to be part of our max engine force, or for principal reasons, I guess we could do it, but gear ratios selected gear minus 1. So boom. Okay. So our max power is now going to be throttled up by our gear ratio, and let's see how well that works. There you go. All right. We don't have a whole lot of power because of our power curve. And we can see that now we max out our power because we're in that end of our power curve where we're no longer making power. Let's go gear higher, and we can speed up a bit more until we hit our max power curve again. And we go gear higher, and we go even faster. And we go gear higher, and we go gear faster. Let's see what top speed we can now reach with. I wish that I would go straight. Well, I think we're not making enough power to even make a difference between 5th and 6th gear. And again, one of the things that is important here is that our ratios are basically correct, and the way that we distribute powers to the wheels is basically correct. But we haven't given our max engine force any thought. That's just 150, which is a number we picked out of random. And our drag is completely phantom, right? But in principle, our gear system works. We can see that the higher gear we get, the less power we get to the wheels, the slower our acceleration, which is exactly what I want. Daniel, sorry that you missed both the stream. All of my streams will be on YouTube, so you can rewatch the stream if you want. They're not disappearing. Although after the stream ends, I think it takes about half an hour before the high quality version of the stream is actually up. So be aware of that. That you might have to wait a little bit for a recap. Evil Chair Slayer, thank you for your compliments. Yeah, there's the joints, and I'm experimenting with joints, and they're doing my head in. And one of my patrons is busy experimenting with joints as well, trying to make some really good use of joints in VR. But yeah, there's some weird things with that, and it's probably because we're not using the joints correctly yet. But joints work interesting, let's say that way. All right. So let's do a few measurements with this. So yeah, like I said, so the two things that we haven't really got. Well, first of all, this curve is obviously, we could have a look at an engine power curve. So yeah, I guess. Well, we're not even dealing with torque, and the torque curve is probably more important than the power curve in our case. Reminds me that I probably want this one to be a little bit more like that, so that we really want this to be somewhat smoother curve. So I really want to, go pretty quickly to max power, and then at the end we sort of stave off. And the nice thing there is that once it goes below a point that we're no longer accelerating, we are now starting to decelerate, and as a result, we're going back up to the power curve, and we sort of get this balance point, which is then our max speed in that gear with the amount of power our engine has. So we get a maximum speed there. Now, normally, what would happen if you do this is instead of the power curve, the engine really losing power, the engine doesn't lose power at all. The curve actually keeps going. The reason why you've got this flat off is because you hit the rev limiter in a real car, right? So again, one of the things that happens in games is instead of us actually really hitting a rev limiter, we simply detect that we're on that downward slope of the power, and we actually animate our rev limiter to pretend that we're actually hitting the rev limiter, while our feedback loop is just hanging out at that maximum speed. So those are the sort of tricks that you do. And it's the same thing when we're in neutral, right? In neutral, all of a sudden, we're letting go of all this logic and going with there. So playing with that power curve, that can determine how well our car drives and how well our car accelerates. Obviously, we need to play around with our maximum engine force to get something that is more realistic for this car. But the other thing, which is really not set up right now, is how much drag we have, how much slowdown our car has. Now, I don't know if I did anything. No, our linear damp is just -1, so it is purely the damp that we have in the vehicle body, which I think is all set up in how our wheels are. So you got a roll influence. Yeah, I'm not quite sure. So yeah, so those are sort of the things where we need to play around a little bit more with settings. What I do want to do right now, just for fun, is I want to add in some measurements and see, because we have some measurements here, right? We've got a 0 to 60. We know what that is, and we have a 0 to 100 and a 0 to 120. Well, with our current power curves, we're going to be way off. But let's see how close we can get by playing around with our power. So let's go and measure those. So I'm going to go back over here. Where's our process here? So I'm just going to say var measure 0 60 is true. Time 0 60 is 0. So let's do that one first and see how well we can implement this. So the idea that I have is if our speed, so let's actually go and put some of these in. Okay. Speed. Boom. We obviously want to have that one. So what we're going to do here is if our speed is smaller than 0.1, we're going to reset. So in this case, we're going to say measure 0 to 60 is true, and time 0 to 60 is 0. Okay. Else if measure 0 to 60. So if we are actually measuring that guy, actually I want to go and put that over here. Boom. And here what I want to say is if speed bigger than 60, then measure. So now we finish measuring it because we're going faster than 60. And else we're going to actually add delta to our time. Cool. And I want to put this on a separate line. So we're going to say here var info plus is oh, that's not var, that's just info plus is. What I want to do is I want to put a new line in here, which also means that I actually want to have our label a bit bigger. I don't think that actually matters. I think it'll draw it outside of bounds anyway. Anyway, what I want to do here is 0 to 60. There we go. Time 0 to 60. There we go. Let's have a look at what that looks like. Okay, so standing still, our time obviously is going to be nothing. Let's see if we go and speed up. We've reached 0 to 60 in 2.28 seconds. Okay. What does our thing say that we should be doing? 3. So we're actually accelerating too fast. That's interesting. I think our drag is probably too low. Let's see what we do with 0 to 100. Okay. So here we do the same thing. Because the thing that I found interesting is that I couldn't get up to maximum speed. I think the max speed of this car is something like top speed 250 kilometers per hour for the model that we're doing right now, and we topped out at around 200, I think, where our power and our drag were starting to get into balance. So that is really something where we need to figure out, okay, what are we doing wrong there? So again, if our speed is small, actually I want to go and do an else here because it doesn't actually make sense to do that. So, same here. 100 until we hit 100 kilometers per hour. That is not 0, that is false. Which also works if you put it 0. That's fine. Here we go. Let's see how we are going to be with that. Boom. So I want to. Oh, we forgot to actually put it on the screen. So 0 to 100. Actually, let's make that a new line. I kind of like that, having that on a separate line. There we go. See if that aligns. That will be very interesting. Let's have a read through. Yeah, Nathaniel, I can't help you yet because I haven't experimented with joints enough yet, but they do drive me nuts. Eventually we'll figure it out, I'm pretty sure. The terrain in this case is just a flat plane, so it's just one big flat plane. So it's there's nothing in here. This is just a test scene so that I can test the acceleration. All right, let's have a look. All right. And we're doing everything in first gear. We're not even switching gears, which is one of the things that I find really interesting and wondering if we're not doing something wrong. 3.37. So what's this time here? So that should actually be 8.9 seconds. So we're definitely accelerating a lot faster than we should. All right, so let's see what happens if we actually. Well, one thing is, the question is our power curve too optimistic? That's possible. think we could definitely do with a power curve that's a little flatter. Oops. Let's try that first and see what happens if we do that. Oops, forgot full screen. Again, let's wait until it settles down. Boom. Wow. Oops. And well, it's interesting that the 0 to 100. Is that really that much? That doesn't make any sense, actually. The 0 to 60 time is 3.1 seconds. Then the next 40, there has to be a gear shift in between there. I can't imagine. I still think that we're potentially doing something wrong with the max engine RPM. Forgot to record how much we were, because I think the acceleration 0 to 60 still makes sense. It's just we keep accelerating, we keep making more power. Again, unless we should actually mimic a torque curve. That's also possible, right? So when we look at a torque curve, that sort of bottoms out at the end and then slowly slows down again. We can try that. I actually want to go and get rid of that one. That one actually doesn't make sense to me. So let's make this more like a torque curve, which is power and then a slow descend down to power. There we go. Let's see how that changes our behavior of our car. Because we might actually find the end of our first gear much quicker as a result. So I needed to shift there. Okay, so how fast can we... Because again, you know, what car goes 120 miles per hour in second gear at 7,000 RPM? It's possible. It is a race car. You know, these Caterhams are bloody fast. But yeah, with this power curve, we can see that our third gear hardly has any power left to do anything. So I'm wondering, what is the limiting factor right now? What is slowing us down? Besides the fact that we're not driving an exact straight line, which is annoying. Able to get a little bit more speed out of fifth gear, but not much. And sixth gear hardly does anything. So there's definitely... We definitely need to look at what is actually causing our friction. Oh. And we stopped right away. Which is logical, because throwing it in reverse like that will probably break any car if you try and do that. Because that's the thing, you know. I remember when I built this the first time, you know, I can't remember doing anything different other than maybe, you know, overlooking something in this. I'm actually going to move our power curve more to what we had, because that did make more sense to me. So what is actually causing the car to slow down again? Because that's the thing that I don't get, is that right now when we look at our car, we don't have a linear damp. So it's not slowing down based on the physics bodies. It has to be slowing down based on drag that's on the wheels. So that's our suspension damping. That's not got anything to do with it. And that's just the balance. So we've got that friction strip. So that's all the way to 9. So I wonder how... Because that's more... Okay, do we lose any do we lose any traction on the wheel? Now, obviously, we don't actually have friction settings. Oh, our test track isn't open anymore. Because we're using that CSG box. We don't have a physics material here, so we don't actually have any settings on our ground plane for that. Because I remember that's what I was playing with when I built this for real. Is I actually gave my car a drag. So let's actually try that. So if we give our car a linear dam, so that is did it tell you to be a small number or a large number? And I don't actually know. Let's just do it like this. Let's see what happens. That's probably way too small. But that's basically mimicking air resistance, right? So let's see how that's influenced our time. No, I had to, not by much. But I think that might be a number that's way too small. So let's, geez, what I'm doing. It's getting late, that's what I'm doing. Yeah, the car weight is set in the car properties somewhere here. So obviously that is taken into account. Okay, so now we're at 4 seconds. And the problem that I now had was that I didn't shift up again. So hey, that's actually starting to look more like what I would expect it to look. So a little bit of drag. I don't know what the drag coefficient. What is the drag coefficient of this thing? Do we have that somewhere? No, we don't have any drag info. That's a shame. Okay. However, let's go and give it a bit more power. Yeah, let's wait until it settles. Okay, now we're stuck at 99 kilometers per hour in first gear. So that's not a very accurate timing. Interesting to see how much difference that power change made. Now you can see that now up to gear 4, 5, and 6, we actually don't even have enough power to accelerate anymore. So we're definitely getting more drag from somewhere on higher speeds. Well, I definitely know that that is too much for our current setting. This is where it's really shame that I don't have my original project anymore, because I had the timing there pretty accurate. But I do remember that I did more with setting up, figuring out what the friction was and all that sort of jazz. And I also did more with the starting RPM. So we definitely, again, I find it really interesting that we're able to get all the way up to speed in gear 1, and then like we see here, by gear 4 we just don't have the power to do anything anymore. Okay, if we put this lower, does that mean that we have less drag? Could be. Hey Michael, how you going? Yeah, we're having some fun with this. Yeah, now we're suddenly our 0 to 100 speed is very crazy. But again, the weird thing that I find is in the first gear we have a lot of power, and then second gear doesn't do that much. Third gear doesn't do that much. Fourth gear, there's just no power left in the higher gears. Now, could it be because we got our power curve just too conservative? Maybe that needs to be even further up. Although again, I don't actually believe our first gear should get us all the way up to 100 miles per hour. That doesn't make any sense to me. No, first gear gets you to what, 40 kilometers per hour? Sorry, kilometers per hour, not miles per hour. So it should definitely be putting a lot more power to the wheels. Okay, finalize that. So I think we're missing something in our RPM calculation. Our RPM calculation seems to get it too high. So what am I doing wrong here? Evolutions per minute. Now, one thing that I want to make sure is there's not some crazy rounding thing, because I'm starting with integers. If we don't have it, we just go out of there. Oh yeah, the car weight, just to let you know, is actually one of the standard rigid bodies. So you give a mass or a weight here. So this car is 575 kilograms. Does that make sense with what we have here? Yep. So I think I used this Wikipedia page before. So that is good. But I think I'm missing something here. Current speed in meters per second divided by the size of the wheels in meters gives us the number of rotations per second of the wheel times 60. Then we multiply that with our final drive, which gives us the rotation speed of our drive shaft, which we multiply by our gear ratio, which gives us... Okay, am I missing one more gear? Right, because that is my final drive. Or is the final drive in our... Am I missing something here? Am I missing another factor that we need to multiply by? Because I am working on the presumption that our final drive, yeah, that's the gear ratio on our differential. Give me a calculator. Where is my calculator? Let's work our way back. Calculator. So, our maximum power is at 7,500 RPM. In gear 1, oops. Gives us a drive shaft speed of 2,800 RPM. Gives us an axle speed of 831 revolutions a second, or per minute, sorry. Okay, let's make a note of that because I'm going to forget that. 831 on wheels. Okay, so actually one of the things that I remember, let's see, our rear wheel has a radius of 0.32. Okay. Cylinder. What did I just say? 0.32. Okay. 0.32. 0.32. 1. Boom. That seems about right. I'm just wondering if maybe there was a mistake there. Okay, so 0.32 times 2 times 3.1415. Close enough for... What? What? Why did it bring that up? I am in this field here. There we go. So that's a radius of about 2 meters. Okay, so we got 831 rounds per second per minute times 2 meters. So we're moving that many meters per second. Oh, sorry, per minute. Sorry, we're working on per minute. So times 60 is per hour divided by 1,000. So that's 99 kilometers per hour. So really, can you accelerate all the way to 100 kilometers per hour on first gear in a Caterham? Maybe. It seems excessive to me, but this is a race car. No, I'm calculating the other way around. I'm calculating the RPM from the speed that... So I'm working my way back from how fast our car is moving to what engine RPM would equate to, to the car going that fast. So we're doing it in the opposite order. And what I just did on the calculator there manually is working from RPM to speed of the car. And that's just a matter of applying your gear ratios so that you know how fast your wheel is turning. Knowing what the circumference of the wheel is so that you know how much you move forward after one rotation of the wheel. And then you can figure out how fast you're going. So unless I'm overlooking something really, really stupid, that looks like we're doing that right. I'm pretty sure I'm missing a step. I'm pretty sure that either either I'm missing a ratio somewhere, or I'm forgetting to go between, yeah, it's meters per second. Yeah, because I'm getting that. I'm not even using my kilometers per hour. I'm using my meters per second. So I'm doing it times 60 to get meters per minute. And I'm dividing that by my wheel size, which means I get rotations per minute. Which I then do times my final drive, so that I get my rotation per minute of my drive shaft. Then times my gear ratio, which gives me my RPM of my engine. All right. You know what? All right. Those are quite a bit higher, so. Well, the other thing, of course, is I'm going all the way up to 7,500 RPM. I never drive my Camry that fast. So, you know, I'd normally go up by that. 3.9. Oh, no. Sorry. Right. 3.944. That's my actual RPM. Let's assume the same wheel size. That's meters per minute. Meters per hour. Yeah, I think our calculation is right. So, yeah, that's about right. I shift up at 25 kilometers per hour in my Camry. So yeah, I guess with the Caterham, with that sort of gear ratio, you can pull to almost 100 kilometers per hour in gear 1. It doesn't really then make sense that we get, again, unless, you know, now that we've got our dam set, and actually I'm going to turn this back to 0.1. And what I really want to do is, I'm going to go back to our torque curve. So pretend this is a torque curve, but I'm going to add a bit more power. So let's see what that does. Well, we'll definitely accelerate too fast. Oh, and I forget to shift up again. Yeah, I'm not even reaching. I'm just really running out of power in the higher gears. Yeah, even in 5th gear, I'm losing power right now. Okay. But in 1st gear, I definitely had more power than I should have. Maybe I should flatten this a bit. see what happens then. Now, to some extent, it's a lot of just playing around with the power curve and the maximum power that we have. Oh, shoot. Oh, that's weird. Break, I'm actually slowly moving. Okay, weird. That makes no sense. Yeah, so... yeah, and then after gear 4, I just don't have enough power to offset drag. I think a lot has to do with the you know, I'm either losing grip somewhere on the tires, or there's something. There's something in the simulation that doesn't seem to be working the way that it should. And I'm not going to find an answer to that tonight. I don't think so. Hi, Ivan. Yes, it's already midnight here, so... yeah, exactly. It's and again, the problem that I have, answering Joseph, the problem that I have is that I had this working properly. And one of the things that obviously got us really stuck at the beginning is when I actually turned this into, or when I started off with a static body, which is really should be, our vehicle simulation just failed. So it's like our raycasts are not raycasting with static bodies properly, because in the end, our wheels just have raycasts pointing down, and that's how the simulation of the suspension works. Now, once it's figured out that the wheels are on the ground, and specifically that they're wheels that have traction are on the ground, it is going to do a friction calculation between the ground and the wheels. Now, one of the things that's already really interesting is that we've got these friction slips set to 9, which is really high. So I don't know whether I set that smart or not, but that should prevent us from slipping. Now, that is combined with the friction settings on our ground plane. But because we're right now using a CSG box, we actually don't have that information, which is just weird. So the other thing that we could do, which is a bit of a hack, because again, the really weird thing was that it seemed to be that the size of our static body affected how well things work. Now, that might actually be something to try out. So let's go and change this back to a static body. There we go. And I'm going to turn the collision shape off here so that no longer applies. And we're going to put a normal collision shape here. So what I want to try now, I'm going to put a box shape here. And I'm actually going to make this equal sized. But it means that we also need to put that quite a bit down. Because I'm wondering if the uneven shape had anything to do with the fact that it was misbehaving. Now, you can see that because I've now got a really large static body, we get this, which makes no sense. We've got a flat ground, a flat plane. Our wheels are completely governed by a raycast, which should be, should not be affected by this at all, unless our margin has got something to do with it. It's not impossible that a margin is screwing things up. You can try. No, it makes no difference, which I'm not surprised by, because it's a raycast. It's just going to hit that thing. Now, the other thing that we could try, even though Godot is now giving us errors on that, but I don't care at this point in time, is we're going to put an infinite plane here. Oops. Good old plane. Which it lands on just fine. Let's see if it changed our behavior of a car in any way. Doesn't seem like it. But with that working, we can put a physics material here. We're just going to give that maximum friction for now. So again, I wonder if those friction settings on the wheel make sense. So let's go and put those back to a normal value. Oh, these are actually higher. So I'm going to put that back to 1. I'm going to put that to 1. I'll put that at 1. And I'm going to put you to 1. Let's see if that makes any difference in the behavior of our car. Definitely is drifting a bit now. That's fun. But that makes absolutely no sense. Plus that we don't even have any power now. Looks like our friction settings are meant to be higher, which let's move them all to 10. Now again, I don't know if the friction is doing anything to slow us down. Or if any of these settings have anything to do with slowing us down. I don't know. Or whether there's bugs that were introduced in the whole vehicle mechanics, which is also possible. I do remember having a lot less problems with this when I wrote the first version of this. Oh, we're no longer sliding, which is kind of nice. We're also maxing out at 4th gear. I don't think we're going to find an answer on that tonight, but we have all the principal logic in place. So it is now a matter of finding out where the drag on our car comes from, because that's really where the balance lies, is the power of the car pushing the car forward and the drag slowing the car down. That is ultimately going to determine how much power we have left over in the higher gears, because we're obviously lowering the amount of power that we bring into the wheels by going down in gears. But yeah, I don't know what maybe this damp is too much. Let's put it to 0 on. Because again, the higher the speed, the more that damp is going to be a factor. So you can see that now we do manage to get faster. Although 5th and 6th gear don't do much. Too close together. But our 0 to 100 is way too fast. So, I don't know. I don't know. Somewhere we must be losing power. And I don't know enough about the physics engine to really figure that out. To know what Godot is doing there. The differential gear is included in calculating the RPM. So that bit I think we got right. I'm not including it in the power simply because, it just means that your max, or the factor that you multiply it by to get your actual, power to the wheels is just going to be, whether you do 3 times 10 or whether you do times 30, it doesn't matter. It's the same value. Hi, Mateo. The only thing that I can imagine is that as we're shifting down, or shifting through our gears, and the power that we actually end up sending to the wheels gets a lower and lower fraction, is that's not a one-on-one factor to the gear ratio. That's the other option. I might have simplified that too much. So yeah, that might be a part of it. I'm going to move this a bit more up, because this is the other thing that I'm wondering about. Is our power curve not flat enough? That's a possibility. Although again, the thing that I have is that in first gear, we just have way too much power. And we should be seeing a result of that. You can really see that now. Lowering the power there, we just don't have any usable power left between gears 4, 5, and 6. So that's weird. I do believe that balance between power and drag, or whatever it is that slows us down on higher speeds, is not working the way that it should. Yeah, James, that's the one thing that I tricked around here a bit. This is more like an electric car in that way than a gas car. That's something that I do plan to change. Where, and again, maybe that's where obviously, you get some loss of speed at the beginning, because you're basically revving up to 3,000, 4,000 RPM, then letting go of your clutch, which in a game is basically you're revving up while you're in neutral, and then you shift, and instead of us directly going back to the 0 RPM that we have because we're not moving, we are taking into account the RPM of the engine that we had, and sort of lerping between the calculated RPM at that speed and the actual RPM that the engine is at this point in time. Yeah, that's the other thing. We were playing around with that, looking at the power curves, where indeed you've got your torque curve more like that, and we're right now using our power curve. So you get more of a scenario like this, where our maximum torque is actually more towards our middle RPM, and then slowly we're losing torque as we go. We can have a look. Oops, that's not what I had in mind. Okay. But the well, now we got way too much power. Cycling up way too quickly. So maybe back to 150. And maybe I shouldn't be cycling the power down all the way to 1. That's the other thing, actually. We'll have usable power all the way till the end. But at some point, that just balances out. We'll see. The other thing that I'm really missing is that I don't have sound yet. I think there would be a big difference if I could actually hear the sound. So actually, I'm accelerating way too fast still. But then the higher RPMs are not really, the high gear is not really doing anything efficient anymore. And that's the thing that I find strange, is that in the low RPMs, we seem to have way more power than we should. And in the higher gears, we just don't have power. And well, one thing that we could do is we actually could increase our damp. So that's really, so this should mean that we're hardly going to be able to move once we get up to speed. Yeah, we're actually don't have anything in the higher gears now. Nah, that's not really working either. I was hoping that we could really increase the power a bit. I don't know. So yeah, that's definitely a stupid number. Let's actually take out. You know, let's assume that we don't have any drag on our car. That's actually going to be interesting, because that should mean that if I let go of the gas, I should be going at a steady power. But I'm actually, see how I'm slowing down? And now I've let go of my gas, and I'm slowing down. And that's what we're fighting. Oh, that's because oh no, that's only if I go smaller than, that doesn't make sense either. That's how I fake my low power end if we're starting up. Well, I could put that back to 0, just in case that is the thing that's slowing us down when I let go of the throttle. I don't think so. That's just to keep us from moving when we're standing still over here. let go, we can see that we're really losing speed very quickly. So I don't know where that drag is coming from, what that drag is being caused by. Am I missing a setting somewhere? Did I have a different setting? No, because we just have engine, force, brake, and steering. Which reminds me, oops. Should change that back to 0, because that's just that I want to brake when I'm always standing still. Yeah, because that's really what I need to find out. I need to find out where is the slowdown coming from. If I'm not giving any power to the car, and I've not set any linear damp, what is slowing the car down? Because you can see how much it's getting slowed down. It's really slowing down quite drastically. And I think that is my problem. That is where I'm getting an unnatural amount of friction. Now, when I let go of the power, the car should be coasting. It's fine if it slows down a little, that's normal, but not as much as it is. Yeah, the car engine sound is definitely something that I haven't figured out properly yet. You know, obviously I know the trick that everybody uses in old games is you have a loop sound that of an engine running at a certain RPM, and then you just pitch that up as your RPM goes up. It works, but that's about it, really. I watched this really cool video, this tutorial that someone made, where they're doing engine sounds in what's that sound tool called? I think it's for Unity or Unreal or something like that. Where they're really procedurally generating the engine sound and combining sounds from accelerating, so actual, you know, the explosions in your engine basically, but also, you know, when you take your foot off the throttle and there's no more gas going in the engine, it makes a different type of sound, and between those pitch differences, and mixing those two, mixing the sound of, you know, what the engine makes as there is gas exploding in it, and the sound it makes as it's decelerating, as you're, you know, put your foot off the throttle, and the sound it makes just by everything that's turning around. By combining all those sound fragments, it gave an incredibly realistic engine sound. Unfortunately, they showed how the end result works and not how to make a procedural sound engine like that. It was a bit of a shame. Yeah, exactly. One throttle open, one throttle closed, and you mix those. It does sound that you got a lot further than I did, James. Really cool. As far as Facebook account, you know, time will tell whether that really is a bad thing or not. I don't know. I think an account is an account. Even if it's with the Oculus account, you know, don't kid yourself. They can link up your Oculus account with Facebook account. If they want to know things about you, they want to know things about you. I'm more concerned about what they do with that data and the fact that there are no laws in place and there's no knowledge with law enforcement, because, you know, the people who make laws, you know, whether it's in America, whether it's here, it doesn't matter. They don't understand this new world. They just don't. They're still living in the 1960s or 70s or whatever, you know, the pre-internet days. And you can see that in the way that they're trying to legislate things on YouTube. You know, you look at the fact that I'm running a YouTube channel, and I have to tick that my videos are whether they're meant for kids or not, because somehow that's going to safeguard kids, and I'm all for safeguarding kids. I've got 2 kids that I'm worried about. They're doing their things on the internet. They're at an age where where they could potentially see things they shouldn't be seeing, or be introduced to people that they shouldn't be introduced to. But the lawmakers have no idea about what actually makes sense and how they actually need to govern these things. And as a result, it's a free for all for the companies that are out there right now. That'll change, as the world wises up and we figure out more. Then at some point, we'll have things in place that weed out the excess. Plus, that what I'm really hoping for is, it's a bit of a shame that HTC seems to be sort of out of the limelight with their Android-based headset. But eventually, especially the more successful the Quest gets, the more likely it is that other vendors will enter the market and will have some competition. And if there's one thing that stifles a company doing these things bad is real competition. That's the thing that we're missing on the phone market. Yes, you've got Android phones, but the Android market is a separate market from the Apple market. There's no overlap there, and therefore Apple has a monopoly, and therefore Apple gets away with things that they shouldn't be getting away with. It's all because they don't have a real competitor. They don't have a competitor in their market segment of the mobile market. And time will tell whether the same will apply for mobile VR. It's a different kettle of fish on PC VR. First of all, we have a lot of choice between all the Microsoft headsets. We have the HTC ecosystem. We have the Oculus ecosystem. We've got the the Valve Index now. So if one of those vendors does something stupid like requiring me to link up with an account that I might be worried about my privacy, I'll buy a different headset. So that just has to happen on the mobile market as well. But I do think right now, when you look at all the things being said, I think it's all very overstated, and people are far more worried than we should be. In the end, you need an account to use these devices, because you need an account on which to buy the software that you buy, and we tech people, we love to just we download our little application and we push it up to we sideload it onto our phones, and we don't want to deal with what the vendor does because we don't care. But that's the 1% of people who use these headsets. The Quest is meant as a consumer product. It's meant to consumers. It's meant to people who would otherwise buy a console, or who are tired of their waiting for the next PlayStation 5 game. They want a new experience. Buy a Quest. They want that App Store experience. So you need an account for that. And whether that is an Oculus account or whether that's a Facebook account, you're still providing your data with the same people, and especially the moment that you need to buy a game, they'll have your payment details, and that's pretty unique to you. So they can track you. I don't think an account matters there. I think that what matters much more is, okay, if people are tracking our data in a way that is detrimental to us, that is abused, then that is something that law enforcement needs to get involved with. And we need a law enforcement who understands how to deal with those things. It's not whether you link your Quest to a Facebook account or not. At least not in my opinion. So, I've got my account linked to Facebook, and there are stories out there, obviously, especially people who get banned on Facebook and then all of a sudden lose access to Quest. That's ridiculous. But again, that is, those are the things that are now coming to the surface where if Oculus doesn't have a proper answer to that, especially once something like that happens to a person who's important to the community, which is very likely. It's I think I said it the other day on Twitter. You look at Tim Sweeney from Epic. He's very politically active on Twitter. He's constantly, his whole lawsuit with Apple is maybe not political. It might not be the right word, but it is possible that at some point in time a dev who has a large impact on the community is going to do something on Facebook that is going to get him banned, whether it's permanent or temporary. Especially with all the election nonsense going on in the States, and all of a sudden it'll blow up in Facebook's face. That will happen, or they wise up in time and they figure out like, hey, hold on, we've got all these people who buy hardware from us, and to whom we now have a commitment because they bought hardware from us, and we can't just suddenly break the hardware because they're a fan of the wrong political party. That doesn't work. Actually, Ishmael, you wouldn't believe it, but there is actually a VR game centering around cats, and it's really, really cool. So yeah, go check that out. Can't remember the name of it though, but yeah, cool. Yeah, when you look at what the Quest is, the hardware, as cool as it is, and as big a fan of it as I am, because I really love what they've done. I'm a PC VR gamer, right? I don't think mobile has the power to compete yet. But it's not, I'm not the market segment for these devices. I want to play my Half-Life Alyxes. I want to play my Boneworks. I want to play those sort of games. The high-end AAA type VR games that are now slowly coming to market. The Quest is a console device, and I look at it as the difference between Nintendo and Xbox, right? Or Nintendo and PlayStation. Xbox and PlayStation are going for the fastest consoles that you can have to run all these big AAA games on. And Nintendo comes out with a Wii, which is a quarter of the power of the consoles on the market at that point in time. I don't know if they went up to the PlayStation 3 or was the Wii around the time that the 4 was already out. Can't remember that. But it didn't matter. Nintendo made games that people wanted to play because of the type of games they are and how well they are put together. And that they had simpler graphics didn't matter because these games were really a lot of fun to play. And especially within the new Wii remotes, which was unique and new. And that's the market that the Quest is going after. When you then look at, okay, hardware-wise, there's a lot of specialty in there. But it's an accumulation of where the VR market has been heading to. Looking at that, Microsoft came out with inside-out tracking much earlier, and Oculus just improved on that. You've got the panels that are now being used in. How different is it between all the headsets, really? The design of it is pretty fixed now. We now know the ingredients of the current generation of VR headsets. So you're absolutely right. I don't understand why there aren't more competitors who are seeing the success of how Quest sells, who are bringing similar devices on the market. The only thing that I can think of is the patents that Oculus might hold, or that HTC might hold, or whoever holds the patents, right? The thing that is a big difference, though, and I think that is where a lot of people, a lot of companies have a like, hey, hold on, this is too risky, we don't want to step in here, is the hardware is only 30% of the equation, right? But it's far more important if you want to bring successful hardware onto the market. is that you've got games. That's the breaking point, right? If you don't have the ability for someone who buys your device to immediately have access to hundreds of the most popular VR games, this is where you see the difference between the PlayStation VR, which came out really early, and I commend Sony for that so immensely. But the PlayStation VR was really hindered by the fact that there were only a handful of games when it came out. And then there was this long dry spell. And I remember very clearly that, I got this disillusioned with mine, even though I loved my PlayStation VR. By that time, I actually had a proper PC VR headset. There was much more available there. And I never looked back at my PlayStation until, a year later, and I went onto the store and it suddenly went like, holy crap, there's a lot of games out there now. That's what the Quest did much better. When the Quest came out, I'm pretty sure Oculus could have released the Quest much earlier. But they waited until they had a collection of games that they could sell. And they had, because 30% is the headset, probably 40% is the games, and the last 30% is the fact that you have your systems in place. You've got your store in place. You have the fact that someone gets the headset and doesn't suddenly go like, okay, I've got nothing on this headset. How do I get a game on this? If they need to go the way that we are used to on PC, where you go to a store online and you download it and you then have to push it onto a device, you're going to lose every consumer. That's fine for us type of gamers, but for your standard consumer gamer, that's not going to be good enough. They want to put the headset on, go to a library and say, buy that one, buy that one, buy that one, and I can play it. That's what I want. So you have to have all that in place. You have to have those games in place, yeah. And that I think is the factor that holds people back. That's also, I think, why PC VR is going strong, because you don't need that on PC VR. As long as your headset works on Steam, every VR game is suddenly runnable on your headset. So if you bring out a headset that competes on price, or if you bring out a headset that competes on quality, you will find a market there. But I think for the mobile one, it's much harder. We'll see where it goes. Oh yeah, yeah. If you have cats, I'm for me it's not cats. For me it's birds. My wife loves birds, so we have a bird. The birds love chewing on our cables, so the bird is not allowed anywhere near this room. Yeah, problem. Cats are a bit harder to keep out of your room when you're playing, especially if your cats are used to roaming around. A flat-out car? You mean a demolition derby? That would be cool to do, but there's a lot of research going into that before we can build something like that. Hey, 20 people for me, that's not too bad as a stream. I'm a pretty new streamer, so I'm happy with 20 people. So pretty cool stuff. And looking at how many people watch the streams afterwards, and I still need to turn some of these things into proper tutorials. I'm happy enough. So, but yeah, type of people. I mean technical people, right? I mean programmers, people who don't mind figuring out how something works, and going through the motions of, I need to download an application and then I need to use ADB to push it onto my phone in order to run it, or onto my device in order to run it. A consumer, a person who is not required to know how computers work and how to do these things. The type of person who is used to going to the store, buying a console, buying a CD, hooking it up to the TV when it's home, putting the CD into the drive, and they can play, right? That's your market when you look at something like a Quest. If someone goes out, buys a Quest, and just uses it. And my hats off to Oculus, how well they. And when I got my Quest, I was so pleasantly surprised by the whole onboarding process. And I hope that they are retaining that, because that is something where it was interesting that they had the phone app, and that is the one thing that I do with questions with, that I don't think they advertise that good enough. I think if you buy the Quest and you don't realize you need a phone to make it work, because you need to have the app installed on your phone. Yeah, that might be a surprise for some people. Most people have a mobile phone, so I don't think it's a really big problem. But and I understand why, right? Because the problem is your very first step is creating that Oculus account, and now today creating that Facebook account. So setting that up requires you to type, which is something that is hard in VR. So having that first step on a phone that is then connected to your headset to do that initial setup with, so that you can actually use your fingers to properly type in the things that you need to type in. I get it. That was actually a really smart idea. My only beef with it was not knowing that was what they've done when I got the device in. But that was, once you do that step, you then put the headset on, and everything from that point, from the see-through camera, so that you can look around yourself. You paint your Guardian area where you want to play, immediately going into an environment, your home environment, where you can see what's installed on the headset, and you can immediately go to the store and browse all the games, and you can just point at them and download them and play them. That's a well thought out system, and I think it is that. I think that is where it's hard when you look at historically that hardware vendors are really terrible at that sort of stuff. Hardware vendors tend to want to build the hardware and then leave it up to the software vendor to write the software, which I think is why IBM computers took off with Microsoft doing the operating system. While Apple was one of the companies, of course, that understood, like, okay, that disjointed way of thinking doesn't work. You have to be a good hardware developer, but you also have to be a good software developer, because it's the software that makes your hardware work. And I think Oculus understands that as well. So. Ishmael, aren't we going to redo all the texturing once we change the models again? Anyway, guys, yeah, it's 1 a.m. for me, so for me it's about time to go to bed, I think. So I hope you guys enjoyed what we've done, revisiting this project. We have a basic gear system. Now, I'm trying to do this with realistic gear ratios. Obviously, there is still something that is slowing the car down. Maybe I'll figure out what that is, and then all of a sudden, if I have control over it, because it is a balance, right? It's the gear ratios that they slowly go down mean that you have less and less power to accelerate the faster you go, but it's also the drag of your car slowing the car down, and a balance between acceleration and drag at some point being reached, which gives you the max speed of your car. And what we really have right now is that drag force is way too much, which means that the car is overperforming on low speeds and underperforming on high speeds. And I just need to figure out, why is the car slowing down so much when I let go of the gas, because that's probably going to give me the answer of what did I do wrong, or what did I change that I'm not aware of, or what changed in the engine. That's also possible. That caused that to go wrong the way that it did. So, but all the principal stuff is in place. I do believe that what we built here, the way that we are calculating the RPM from the engine, or the speed of the car, feeding that back into our engine calculation of how much power we can give to the engine, creating a power curve, being able to set that up. I think that's all the groundwork for making this work properly. Still a lot of stuff to do. We have to make sure that we have control over the RPM when we're in neutral. We have to make sure that, if we rev up the car before putting in first gear, that we just not suddenly boom, RPM back to 0, but that the RPM actually sort of lurks between where we were and what we now have, so that we have that extra power to start the car moving forward. And the same with any sort of change of gear, where we don't really want to just slam the change of RPM, but we want to make that a bit more smoother. Rev limiter, making that properly work. Sound, still a thing. So there's still plenty to do with this. Now, I don't want to leave my space game for too long. Obviously, I want to return to my space game. Right now, I'm happy. We did the rigging the last 2 weeks, because that's actually something that I need for the space game. I'm still not happy with where we are with that, but it's workable. I don't mind if you guys want that to spend another day next week on this and sort of perfecting, trying to figure out more about how should this work. That's one possibility. But I might return back to the space game. I'll see. I don't think I'll have time anytime soon to condense this into a tutorial. I do want to return to this. I do want to use what we've done today on stream as like a part 6 for the engine or the vehicle tutorial. But I don't see me doing that until sometime next year, simply because there's too much on my plate right now. So yeah, we'll see. I might spend another day on this next week, depending on whether I find the time during the week to do some of the stuff that I need to do in preparation of the next stream for my space game. Else, we're going to be back on our space game next week. Good optimizations, Ismir. I wonder if that's gonna have an effect on the. Actually, I need to try it out again on my machine, see if it's running properly again. Anyway, enough talk. Thank you all for joining tonight. I hope you learned something out of this. We made some great progress. I'm pretty happy with how far we got. I'm still mystified with this last little thing, but I'm sure we'll figure it out. I'll be back next Friday. So thank you all. And whatever time of day it is, have a good day, have a good night. I'm off to bed. See you guys next time.